Hi everybody, Captain Al speaking. Welcome to FTD 1 today. And we have to read the disclaimer first. Subsonic flight training tutorial briefings are for educational purposes only. The channel gives flight simulation gaming enthusiasts education for the purpose of enjoying their flight simulation experience greater by learning the jet aircraft operation. No portion of the training, though very accurate, is meant or intended to be for actual flight operations. No flows or checklists are to be used for actual flight operations. None of this material presented is approved for flight operations by any authority, the FAA or worldwide authorities, and it's intended for gaming only. Okay, here's our flight plan for today. And for you Patreon members, you can just make sure you have your FCOM available, opened up to the supplemental procedures for the electrical power-up, and then for the preliminary pre-flight procedure after that, and then for the first officer and captain's scan flow, if you want to refer to that. And also have this available, the flight plan itself. The origin is a Boeing Field, KBFI. We're going to be at the Boeing ramp, which is Bravo 4. We'll be departing runway 14 right, and the route is to Orton, direct Vamps, direct Payne, Victor 23, Seattle. When we get the clearance, when we pick that up, even though there'll be no clearance today, we'll add the Kent 8 departure to a simulated clearance, and that'll be part of the amendment to the routing. Will be the addition of a SID. Sometimes SIDs are added to the flight plan. Sometimes they aren't part of the flight plan, and then when you pick up your clearance, you get a SID. We're going to be a Sonic 4.4 Heavy. Our weight today in pounds will be 480,000 pounds. Fuel on board will be 150,000 pounds, and the gross weight will be 630,000 pounds. And again, when you do this on your own, if you're more comfortable with kilos, certainly you can use kilos, and those are in parentheses, just to the right of the pounds. Cost index 125, cruise altitude 9,000. We'll be using full takeoff and climb, flap 10 takeoff, and we'll be using the NADP2 procedure, Noise Abatement Departure Procedure 2, which is sometimes called a distant community. We'll be using the acceleration height of 1,000 feet, engine out of 1,000 feet, and thrust reduction of flaps 5. And of course, the NADP1 would be the normal noise abatement departure profile of an acceleration height of 3,000 feet. Engine out would be, again, whatever your airline uses for engine out. We're going to use 1,000. And the thrust reduction would be 1,500 feet, and that would be for the NADP1, which in many parts of the world, that's what we use. But for training, we kind of alternate between NADP1 and NADP2. Winds calm, slope 0, CG 25. The ATIS information. Winds will be calm, 15 statute miles visibility, sky clear, temperature 15 Celsius, dew point 8, altimeter 2992, and the 14 right is the departing runway. The ILS 14 right is in use. Advise on initial contact, you have Alpha. Clearance, none today, but we'll do something because we got to put something on the mode control panel, so we'll kind of set up something for a clearance. Okay, I'm going to go over the aero links. You should be seeing a fairly dark screen. The airplane is unpowered at this point. External 1 and external 2 are plugged in. I pilot 1 from Poland. Nice to see you here. And we're going to do the electrical power up right now with the airplane completely unpowered. The only thing you really have are the hot battery buses are powered. So you've got an APU hot battery bus, and you've got a main hot battery bus. Those are powered right now. And you also have the ground handling bus powered because you have external 1 plugged in, or APU 1, but we don't have APU 1, so we have external 1. And if you have both APU 1 and external 1 available, then the preference is to take external 1 and use that for the ground handling bus. And the ground handling bus would basically provide the ability for the fuelers to fuel the airplane, or if people wanted to start putting some stuff in the lower lobes, that would power the lower lobe cargo handling equipment and the lower lobe lights. But the main deck would not be powered at this time. Oh yeah, it would, because we have external 2. Yeah, so just being plugged in, external 2 would be available, and then that would allow them to also power the main deck handling bus, and they could start loading the airplane if they wanted to without it being powered, as long as the external power is plugged in. So that's about all we have right now. We have the 2 hot battery buses, and we have the ground handling bus, and having external 2 available, we also have the main deck handling bus. Now we're going to do the electrical power-up procedure, and you guys, the Patreon members, you can follow on the supplemental procedures. I think it's 6.1. First thing we're going to do is turn the battery switch on. And when you turn the battery switch on, all that does is the contactors close, and the main hot battery bus and the APU hot battery bus can now power the main battery bus and the APU battery bus. So you've got 4 battery buses powered now, and that's about it, in addition to what we talked about. The next thing we would normally do would be, after the battery switch, is turn the standby power selector to auto. We've done that. And you'll hear some of the sounds maybe of the stick shaker going off momentarily, and kind of a beep, beep, beep sound. And that simply is there's some tests going on in the background when you bring the standby power to auto. And so there's some bite tests, they call them, built-in test equipment that will automatically do some tests when you go from off to auto on the standby power selector. Now you'll notice that the, I won't go to the captain's flight instruments, but right now the PFD and the ND on the captain's side would be powered. The left CDU would be powered. The upper ICAS, or the upper display unit, which shows primary ICAS, is powered as well. And the next thing we're going to do is check that the demand pumps are all off. And now that I got standby power in auto, if this is too dark, I could always take the storm switch and turn the storm switch on. And that would provide the dome lights and floodlights at their max intensity, so that you can see a little bit better before you turn your lighting up. So this would be the storm switch off, and then turning the storm switch on, you'll see that there's some more lighting. And if you go up here, you'll notice that we've got a floodlight there, we've got a floodlight there, and we have this is the aisle stand floodlight. And so all your floodlights would come on, and all your dome lights would come on at max intensity. On the flight deck, there's actually 4 dome lights. You can see 2 of them in the Aerowinks on either side of the instrument panel, the overhead panel. And then, but there'd be 2 dome lights that are kind of way behind you on the flight deck as well. So we've turned the battery switch on, we've gone standby power to auto, we've checked that the demand pumps are all off. We're going to check that the windshield wiper switches are off, and that's just so that if we were to establish AC power, we don't want them scratching a dry windshield if they started to go. If they were on for some reason and you established AC power, then they'd start to run, and if you had a dry windshield, of course, they'd scratch the windshield. So all these things are done for safety, right? Remember we said that this was called the safety check at one time. And all these are done so that when you establish AC power, nothing's going to move that could cause a problem. And then after the windshield wipers, we're going to come over and check that the alternate flap switch is off. And I like to check the alternate flap arm switch is also off. Now it's not going to move even if the switch were armed. As long as this is off, the alternate flaps are not going to move. But I kind of treat these together. So if that's off, this should be off too. And now we'll check that the landing gear lever is down. We have a down indication. And we're going to check that the flap handle, which is at 0, agrees with the flap indication, which is up. Now you'll notice the flap indicator has expanded, and you'll notice that there's two little amber X's on the left side of the flaps, on the left flaps. And this indicates that the left side transmitters are not powered, and they're not powered when you're on standby power. So it's normal to see an expanded flap indicator. It's normal to see two amber X's. You'll notice that the flaps themselves are clear and the leading edges are clear, which kind of indicates everything's up. And then you have the up indication, but it's not green because the left side transmitter is not powered, so it can't sense that they're green. But that's a normal indication when you're in standby power. The main thing you're checking is that the flaps are up and you have that up indication. You'll notice once we establish AC power, that flap indicator will go back to a single indicator, and it'll say up in green, and then it'll disappear after 10 seconds. So the next step, I'm not reading it actually, I don't have it pulled up, but I think the next step is to establish AC power. And the AC power would be to take the bus tie switches and make sure they're in auto. Remember we said this is something that people kind of mess up on from time to time. And they forget this step. They just go ahead and push external 1. And we want to check that these 4 switches for the bus tie are in the auto position. And they are. And there's no reason why they shouldn't be, but we're checking them. And then we'll go ahead and establish external 1 by pushing it on. Again, the available means that the frequency and voltage are acceptable for use. So we'll go ahead and turn that on. And now everything's going to kind of come to life when you do this. All your displays are going to come up. And let me go ahead and turn these lights down just so we can demonstrate some of the lighting. Oh, the storm switch is on here. Yeah, that's good, actually. Okay, bring that back in. Okay, so now that we've got external 1 on, Mikhail, yeah, I'm recording the stream. I'm recording it. Now that we've got external power 1 on, external 1 is powering the whole synchronous bus. And external 2 is available. And again, if we're a freighter, that's how we want to be. Because the main deck cargo handling bus will be powered by external 2. And if we turn that on, that would disable the main deck cargo handling bus, and we'd hear from the loadmaster and the loaders pretty soon. So in a freighter, we'd leave it like that. If we were a passenger airplane, we'd go ahead and bring external 2 on. Now we could also start the APU at any time, but usually we'll start that as we go through the electrical system. As we come down, we'll start the APU. The next thing we're going to do is the preliminary pre-flight procedure, but before we do that, we'll turn up some of our lighting. So let's turn the storm switch off, and we'll talk about some of the lighting. You'll notice down here on the lower panel of the overhead, you've got the circuit breaker, you've got the glare shield, you've got a dome light switch, and you have an aisle stand switch. And then you have lights for landing lights and turn off and taxi and beacon, and we're not so much concerned about those. We'll get those as we go through the flight deck preparation. But we are concerned about these four controls for now: the storm and the circuit breaker and the glare shield and the dome. Now the dome light, you'll notice if I turn that up a little bit, it's not going to seem to have any effect because the floodlights are on. Anytime the dome lights, you try to operate them with the storm switch on, the storm will always override the dome light switch. So when you bring the storm switch on, that brings your floodlights and your dome lights at max intensity. So it doesn't matter where you put the dome switch, it overrides it. If I turn the storm switch off, now this dome switch will work. You'll notice if I come up here that the dome lights are now much less intensity. You'll also notice that the aisle stand floodlight is not on now because it's just the flight deck and it's just your dome lights and your floodlights at max intensity when you bring on the storm switch. And right now the storm switch is off, and this light is not on because the aisle stand floodlights are not adjusted yet. So the only thing on now is the dome light switch, and we've got it turned up a little bit, and that's why you see the dome lights at a less intensity. So let's go ahead and turn the dome lights up now to their full intensity. And now if I go up, you'll notice the lighting has increased, and of course we can see more as well. But notice the aisle stand floodlight is still extinguished unless I put on the storm switch, and then that'll come on. So I'm going to bring on the storm switch again. We'll bring the dome switch all the way off, and then I'll bring the storm switch back off again just so we can see these lights. Again, here's the circuit breaker overhead panel, and you'll notice that when I adjust that, it's going to bring all my overhead panel lights and my circuit breaker, especially on the P7 circuit breaker panel, those lights will come up to full intensity as well. Yeah, the nav lights, normally, Walter, the nav lights would be on. Right now they are off. But normally, when you get on an airplane, they're usually on. Nobody normally turns those off. So if we did see those off, we'd want to turn them on, yeah. And if I saw them off right away, I probably would turn them on. But you see they are off right now. I'll turn them on as part of the lighting. But normally they would be on. And most of the time when you get on a live airplane, they are on. You'll notice this says the glare shield and panel floodlight. And there's two switches there. One's an interior switch, and the other's a interior and an exterior switch. The interior switch is the smaller inner switch. That's sometimes referred to as just the inner switch, and then there's an outer switch. And the outer switch will be for the integral lights, the background lights, and the inner switch, the little smaller switch, will be for the floodlights. So if we take the bring up the outer switch, you'll notice that my MCP up here, the integral lights have come on, the background lights, like indicate airspeed, Mach, heading, altitude. The numbers are lit up, the LNAV, VNAV's lit up. All this stuff is lit up when you bring that outer switch to the bright position. Notice I'll turn it down, and they go down. I'll turn it back up. These kind of look like they're illuminated, but they're not. They're just white, and they stand out a little bit more in the darkness. And so these actually are not lit up, even though they kind of look like they're lit up. So I'll bring that outer switch back up again, and you'll notice the integral lights come back on. And then if we take the inner switch and we bring that, turn that clockwise, you'll notice that that brings the floodlight on as well. So the inner switch is the floodlight, the outer switch is the integral or the background lights. And you can see the floodlight right here is kind of that white line right here. There's a whole strip of white light on the mode control panel. And again, the dome light would adjust the dome lights. If I wanted the dome lights on full, I could bring them on full, or I could use the storm switch and that would override that. I'm going to keep the storm switch off for now, just so we can see the lights. On the aisle stand, which is down here, you'll notice right now it's pretty dark. And again, you've got an inner and an outer switch. The little inner switch would be for the floodlight. That's the one we looked at that's above the overhead panel. And the outer switch would be for the integral lights. So I'm going to turn up the outer switch first, which is that bigger switch. And I'll rotate it clockwise. And you'll notice that'll bring on all the integral or the background lights. And then if I take the smaller switch, which is the inner switch, and I turn that clockwise, that'll be this one, you'll notice that's going to provide a little more illumination here. Notice we've got some more light here, and that's because you turned on this light right here. That's on either side of there in the inner portion of the P7 circuit breaker panel. We'll go ahead and turn the nav light on now. That'll make Walter feel better that we got some illumination of the 3 lights out there. Or actually 6 lights on this airplane. We've got the 2 green and the 2 red and the 2 white nav lights. And while we're down here on the aisle stand, let's turn up the brightness of the center CDU, because that would have been down. Maybe, if a crew put it down as part of the securing. And then you'll notice the lights over here are pretty dark on the captain side. And that's because the lighting switches for the captain are located right here. And the first thing we're going to do is bring on the outboard CRT lights. So I'll rotate that clockwise, and that'll bring the outboard CRT, or sometimes this is called the DU, display unit. Sometimes they still call them CRTs, even though they are LCDs. Some people still call them LCD or CRTs, but most of them are LCDs nowadays. The cathode ray tubes have been replaced by LCD displays. And so this outer display unit will be for the outboard CRT. And see, even it's labeled CRT, but really this could be an LCD. PVD, we're not going to worry about that. That's the paravisual display. And, I can't remember where the switch is for that, to turn that, to get rid of that. And I've looked in AeroWinks. If anybody from AeroWinks knows where that is, let me know to turn that, to get rid of this. The PFD. I've looked and looked and looked, and I thought I saw it before where you can take that out and not have it, the paravisual display, but because a lot of people don't have that. But that would adjust the brightness of the paravisual display, which is actually right here. Right there is that paravisual display, that little indentation right here. Right now it's not going to do anything because nothing's on to power it. The inboard CRT would be the inboard display. It should be right there. So I'll go ahead and again, notice you've got 2 switches, and the philosophy follows the same. So the outer switch, which is that kind of bigger switch, is for the inboard CRT integral lights. And so if I turn that clockwise, which I'm doing now, I'll turn it all the way. That's going to bring on your inboard CRT brightness. And then you'll notice the little inner switch would be for weather radar returns brightness on the ND. So when the weather radar is on and you have weather radar returns, you can adjust the brightness with that little inner switch. Right now it won't do anything. Map, if we pull that out, you can pull it out or push it in. When you pull it out, that will activate the map light. And then if the switch is off like it is right now, like I have it, you can then adjust the map illumination by rotating it clockwise. And the map light, the little map light, is right here. And it's a little swivel light that can it can go down and to the left and to the right and up, and you can swivel it kind of in a circle. It kind of moves all over the place. It's got limited movement, but it moves so that you can adjust the lighting to wherever you want to look. Normally you're looking, down in your lap because you're looking at something, and then it has a little circular ring where you can adjust the beam intensity. So you can make the beam smaller, you can make the beam wider by rotating the little rotary selector here around the light, either counterclockwise, which would kind of I think that increases the beam, or if you go clockwise, it'll make it focused. The beam will be more focused. So that's the map light way up there. And again, you can push it in to turn it off, pull it out to turn it on. And then the panel lights would be right here, and that's why it's so dark here, because there's no panel lights on. So if I turn the, again, the philosophy stays the same. The outer switch would be, and that's the bigger switch, would be for the integral lights. So I'll turn that up now. Oop, there we go. And you'll notice now all the integral or the background lights come on. You notice we can see like the brake pressure indicator now, and the RMI, and the clock, and the lettering here on the instrument source select switch. And then the inner switch would be for the floodlight. There's a floodlight for the captain and a floodlight for the first officer. So you'll see as I rotate it, now you can see the lighting down here. We illuminated more of the panel with a floodlight that kind of shines down here and illuminates that. So that's pretty much it for the captain's lighting. Now you'll notice that the captain controls his lighting up to about the gear handle, right about here. And the first officer controls from the gear handle all the way to his flight instruments. You'll notice it's dark over here. So the captain pretty much controls to where the primary ICAS is and the secondary ICAS and the gear handle is, if you draw a line, kind of right here. While we're here, let's turn up the brightness for the CDU with a brightness control. And then we'll turn up the brightness for the ISFD. Now, if you had the traditional standby instruments, which are the round dials, that would be part of the panel lights. So when you turn on the panel lights, these would illuminate. But with the ISFD, you'll have a plus and minus switch for the lighting. And if you just hit plus, it'll go ahead and make the ISFD bright. You'll notice here there's switches for brightness for the upper display unit and for the lower display unit. And this is the one I tried to adjust before and it wouldn't turn down. I'm not sure why that's not turning down. Oh, there it goes. It's just taking a while. So let me turn that down and let me turn this. I think I got that. Unless I'm getting the wrong plus or minus here. Let's see. Now for some reason I'm having trouble turning that down. And I had the trouble with the primary ICAS as well, but it did turn down. So if I turn this clockwise, the upper button, or the upper knob here, it'll turn that display up in brightness. And if you take the lower switch, and it's the outer switch, the bigger switch, and you turn that clockwise, oh, there, it just went dark for a second. That's weird. It's not really, I'm not really controlling it that well. Try it again here. And for some reason I can't turn it down. But this is the big outer switch will turn it bright. And then you'll notice there's an inner switch. And that little inner switch is for weather radar returns if you were to put the ND down here. So if you were to have like an outboard CRT failure or an outboard display unit failure, and the PFD would automatically move over here, you could move the ND down here, and then this switch would be for weather radar returns down here, if you had the ND down here. Otherwise it doesn't do anything, that inner switch. So I'll bring that back to normal. Normal would be that the lower CRT is on the ND mode. And now you notice we go back to secondary ICAS here. So that's the brightness for those two. And then if we go over to the first officer, which is kind of dark, we can do the same thing we did for the captain. And that is we'll bring up the outboard CRT lighting. I wonder if it's my mouse. Yeah, I'm having trouble somehow. I'm having trouble adjusting, making the hang on one second. Let me try to get these first officer lights up. Let me come back to that. Let's try the inboard CRT. Oh no, they're up. Yeah, there they go. Let me bring the inboard CRT up. And that would bring the brightness up here. And then the paravisual display, that's right here again. Let's not worry about that. And again, this little inner switch would control the weather radar returns on the ND when you have weather on. So once you have weather on and you have weather radar returns, that little inner switch would control those weather radar returns. And then the map works the same way. You pull it out, push it in. Push it in is off, pull it out is on. Go ahead and adjust the brightness. And then you can see the map light is right here. And again, it controls the intensity. You can rotate it left or right or up or down or in any angle, really, within a certain range, and then control the beam intensity. Okay, and the last thing to do is adjust our panel lights here. Maybe that's what I thought I was doing here. Okay, never mind. I think they are working okay. It's just operator error. So let's bring on the panel lights here. And again, the outer switch is the integral lights and the inner switch is the floodlight. So we'll bring on the outer switch first. Then notice the panel lights come up. And so you have a lighting for your instrument source select switch, your clock, all these switches. And notice again, it now goes to the pretty much to that gear handle. Remember, this was all dark. Well, now it's all lit up because you adjusted your panel lights. And then, of course, the inner switch would be the floodlight. I'll turn that to bright, and you can see you get a little more illumination, general floodlight on that area. And let me bring back to, see, where were we? Over here. Okay, so that should be all the lighting. Now let's move to the preliminary pre-flight procedure. And we're going to bring on the IRSs, the IRUs. Sometimes people will call them IRSs. That's the whole system. The IRU is the inertial reference unit. And we've got 3 IRUs, left, center, and right. If you normally have to bring this switch out and then rotate it. It's got a detent. And so if you just try to turn to the right, it won't turn. You have to pull it out and then turn. And so we bypass the line and go right to nav. So we'll go to nav, nav, and nav. And now if you come over here and you cancel your ICAST messages, you'll see that after about 10 seconds or so, we'll get align messages. So we have IRS align left, IRS align center, and IRS align mode right. And these are memo messages. They show normal operating conditions, basically. And that's coming on just to tell you that the IRSs are in the align mode now. It'll take about 10 minutes for the IRSs to align to figure out where they are in relation to true north. And you'll notice that on the ND, both the captains and the first officers, you have time to align. And it starts at 7 minutes and it counts down from there. Even though it's generally about a 10-minute alignment, it depends on your latitude. The timing will actually start from 7 minutes on down, and then that'll count the time to alignment. And the only thing you have to do is basically give it a present position in order to complete the alignment once that time is up. It's going to determine where true and magnetic north is and go through its process of determining where you are in the world. But then we need to give it a specific position in order for the IRSs to complete the alignment. So I'll go back to recall the messages here. After we bring the IRUs to nav, and remember this is all by memory now. So after we bring the IRSs to nav, we're then going to come down and adjust this. And we're going to check the status page. And since I'm here on the engine page, I could check this first. I'll check that my engine oil quantity is sufficient for the flight. This is in quarts. Sometimes they may be in liters, but here it's in quarts. And Boeing doesn't have a minimum oil quantity for departure. They don't list one. It's not in limitations. The engine can operate with very low oil. So when you get a very low oil quantity, it'll turn magenta. And then that'll indicate the engine's going to have some problems because it's very low. Most airlines will then stipulate the minimum oil quantity for departure. So Boeing doesn't give you the guidance on that. They don't say, well, this is the minimum oil quantity for departure. They leave it up to the engineering and maintenance department to determine what that is. So for our purposes, we'll just use 20 quarts or better is good. Anything under 20 quarts, we could think about getting it serviced. The engine would operate just fine on less than 20 quarts, but we'll say 20 quarts is the minimum for us or better. Anything less than 20 quarts, we'd want to get it serviced. And that's how airlines kind of specify it. They'll put that somewhere in their documentation. And then we'll go to the status page. And we'll check our status messages, if we have any. In this case, we do. We have window heat 1 right, window heat 1 left. Now, I know that that's going to come off when I turn on the window heat, so I'm not really that concerned with that. But if I see something that I don't really recognize, then that may affect our dispatch. But for right now, we'll come back to the status page when the first officer checks it, and we'll make sure that there's no messages here. But for right now, I know these two are going to go away. Hydraulic quantity, we're going to check that it's sufficient for the flight. And normally you're going to see here that it's expressed as a percentage of the normal service level. So the normal service level is 1.00. A lot of people think that means full. 1.00 is not full. It's just considered the normal service level. So 0.98 would be 98% of the normal service level. 1.01 would be 1% above the normal service level. So all we're checking for is that we have, adequate hydraulic quantity. We know we're going to get a refill indication at 0.75 or less. So anything above 0.75 really is good. And normally you're going to see these things up around 0.9 something, 0.95, 1.03, 1.02, 0.98. That's all good. If it does drop to 0.75 or less, you'll get a little magenta RF next to the hydraulic quantity, indicating it needs servicing. And then we'd want to get it serviced for sure. I'd probably question it if it was down to like 0.85, and everything else is up at 1.00 or 0.99, and this one's down at 0.82. I'd want to know why that's down to 0.82, and everything else is higher. We're also going to check the oxygen pressure for the crew and the oxygen pressure for the passengers. And again, this is something that you'd really have to check. There's a performance manual that's on the airplane, and that will have oxygen charts in it. And normally you could check for, let's say, 4 occupants, meaning the captain, the first officer, and if you had 2 jump seaters, you could determine what the minimum oxygen pressure for departure should be. And usually that's the number we check, because if we don't have 4 crew members, let's say we have 3, or it's just the captain, the first officer, because the route requires just 2 pilots. So the route may require 2 pilots, 3 pilots, or a double crew, 4 pilots. But we'll always check that 4 pilots oxygen quantity, because we know that if we got less than that, we're better than that. And normally it falls somewhere around 1,000 psi. So I know if we're up around 1,800 or 1,850, and that's usually what you see, right around this range, I know I'm good, because I'm way far away from where I need to get it serviced. Because the minimum the minimum oxygen pressure is around 950 or 1,000, something like that. So I don't even have to really look at the book if I know it's 1,800 or 1,700 or. And now again, if that were lower, if it's a number I'm not used to seeing, like maybe it's down to 1,200. Okay, now I might look in the book and see what's the minimum and why is it at 1,200? Because it's usually up around 1,800. Then I might question it. But seeing this, I wouldn't even, you wouldn't even need to check. And then once we finish the status page, we could go back to engine. I could turn the brightness up here. We forgot that one. Turn the brightness of the CDU for the FO up. Then we check things like the, again, I don't have it up in front of me, but I think it would be stuff like the logbook. We check the maintenance logbook. We'd have to make sure the airplane's signed off for the day, that it's been pre-flighted by maintenance and it's signed off. We check if there's any discrepancies that are open. And there's a few other things we check that aren't really important, but we check the logbook. Usually in the simulator, in training, there's like a fake logbook, and it'll have papers in it for the airline or whatever, but nothing's in it, And so usually in AQP training, they make it more realistic where they actually do have the real logbook in there, and they will have it signed off, and you'll have to check that it's signed off. So in AQP, generally they do check more. It's more realistic that you're checking that the airplane signed off. But for airlines like Boeing or operators like Boeing, we never do that because it's not necessary in normal training to necessarily check that. But in AQP, where it's more like line-oriented training, then that would be something they'd want to put in there as the logbook and actual sign-off. Then after the logbook, I think they have emergency equipment probably. The emergency equipment would be things like the crash axe and life vests and smoke goggles if you don't have a one-piece oxygen mask with goggles. Sometimes it's two pieces. It's the oxygen mask and smoke goggles. But a lot of them nowadays are just one piece. When you put on the oxygen mask, you're also putting on face goggles as well. Stuff like the escape reels, the overhead hatch on a passenger airplane, all the emergency equipped flashlights, all that stuff's being checked. Whatever's on your flight deck, you're checking all the emergency equipment. And then normally after that, you would check the, I think probably the P6 circuit breaker panel would be next, I believe. Let me go here. And what I'm going to do now is bring up the lights. Let's bring up the lights to the, hang on one second. Yeah, I'm going to bring on the lighting to daylight now just so we can see a little bit better. So after all your emergency equipment, we're going to check the P6 circuit breaker panel. This is behind the FO, or just kind of to the side of the FO, and it goes back behind the FO on his side. And the P6 circuit breaker panel has circuit breakers in it, and you have to be very careful you don't hit these with your flight bag, because sometimes when you bring your flight bag in or out, it could clip one of these for the FO. So there is a little area light. This doesn't have integral lights. It has like an area light that just shines on it, and it's not very bright. So generally we take our flashlight and we look at that circuit breaker panel with a flashlight to see if anything is popped. Some may be collared, and in that case they're okay if they're collared. They're pulled out and they have a little collar around them. But you'll see if one is pulled, you'll see it kind of out, and it'll be, you can't see it here, but there'd be a little white stub attached to this black, the top of the circuit breaker, and you would see one that's popped if you shine your flashlight. We'll check the smoke vent handle is in. That's right here. That used to be the celestial port on the 747 Classic. And then when the 400 came about, they made it a smoke evacuation handle. So if you had smoke on the flight deck and you pull that little port will open up and there'll be differential pressure that'll draw the smoke out. But we want to make sure that's in, because if it was pulled, we'd have a heck of a noise on takeoff if that's open. We're also going to check the overhead maintenance panel, which is above the instrument panel, above the overhead panel, would be the, you can see it here, the P7 circuit breaker panel. And then just above the P7 circuit breaker panel will be the overhead maintenance panel. So it's all the way back behind you. And the thing we're checking for here is that all the guards are closed and all the lights are out, except maybe this one, the split system breaker light. Again, if you were on a passenger airplane, we could have selected external 2, and that would have made the split system breaker open and we would see that open light illuminated. So that's the only light we might see on, is that open light on the SSB switch. But again, the guard should be closed, but you could see an open light here, and that would be normal. We're also going to make sure that the APU start source, we're going to make sure it's in the APU position. Remember, it's got two positions. It's got TR, and it's got the APU battery position. So it's a two-position switch. You can flick it up to TR or down to APU battery. And we're going to go to APU battery because that's the way it's been for a long time. The TRs had some problems early on, and they were overheating, and so maintenance, until they got that TR program or TR situation under control, they recommended going APU battery, and I think they're still doing that. So at least they were when I was still at there. Now I don't know now. I'm not sure, but we'll put it to APU battery because that's how we've been doing for the last a long time, actually. They really haven't fixed that problem with the TRs, so maybe it is just a nagging problem. The towing power switch you may or may not have, depending on the airplane. This is kind of optional in the 400, but if you do have it, we check that it's in the off position. And the lucifer switch down here, we would check that it's off or where the loadmaster put it. Depending on what you're carrying in the lower lobes, he'll decide where that needs to be put if you're carrying flowers or animals or whatever. We don't do generally don't do a cockpit voice recorder test, and we don't do squib tests. These are usually maintenance functions, and so they'll usually do that for the cockpit voice recorder and for the squibs. And they can check the EECs by they don't have to have AC power on the airplane, and they could do a test of the EECs from up here. And then there's some defueling switches here, but all these guards should be closed. All the lights out except maybe that SSB light, and the APU start source, we're just going to make sure it's in the APU position. And if you have that towing power switch, make sure it's off. And then lucifer as required. Let's see. Yeah, and Walter mentioned this one. There is a flight deck access light. Up here it's powered by the ground handling bus. And so generally if you have external one plugged in, it will allow you to put light. It basically puts lights on outside of the flight deck, down on a freighter, down the ladder, and it gives you general illumination to get out of the airplane. There's also a switch down on the main cargo compartment that you can put lights on there as well that will give you a path to the flight deck. So generally, as long as the ground handling bus is powered by external 1 or APU 1, you could push this on and it gives you lighting kind of to get you from the flight deck to the door. And on a passenger airplane, it's door 2 left, and on a freighter, it would be just down to the entry door. And down the ladder, the lights down the ladder and stuff like that. So generally we don't check that. I mean, it would be turned on if we needed to turn it on, but it'll give you, especially when it's a dark airplane and you're getting on it, and external maybe is plugged in, and you want enough lights to get you up to the flight deck, because you don't want to go up there when it's pitch black and dark. So that's what that kind of gives you. Or gets you from the flight deck to the door, if you're securing the airplane. Then we're going to check, let's see, what else is there? I think we're at the point where we can just check that the parking brake is set. And that's if we're going to check the brake wear indicator pins. And we normally do that, so we normally set the parking brake or make sure it's set. And that would complete the PPP, or the preliminary pre-flight procedure. So again, what have we done so far? We've established AC power using the electrical power-up procedure. We've adjusted all our lighting, especially if it's dark. Before we go looking at things, we want the lighting to be illuminated. And then we've done the preliminary pre-flight procedures, and again, that was the IRS's to nav. And then we check the status page, the hydraulic quantity, the oil quantity, the oxygen pressure. We check for any status messages. We checked the logbook. We checked all our emergency equipment. We checked the P6 circuit breaker panel. We checked the overhead maintenance panel. We checked P7 circuit breaker panel. We made sure the smoke vent handle is in, and we set the parking brake. And that's kind of it. Somebody remind me if I missed something there, but that should be the preliminary pre-flight procedure. And then from there, we're going to go to the CDU pre-flight. So normally, again, somebody would start the CDU pre-flight, and normally that's going to be the pilot flying. In this case, we're going to say it's the FO, or the captain could designate who he wants to do the preliminary pre-flight procedure, or the CDU pre-flight. It just depends. Usually it's the pilot flying, but the captain could always say, I'll do the CDU pre-flight while you're walking around the airplane. In many cases, internationally, it is the FO because the captain's walking around the airplane, and they may want the FO to get started on the CDU pre-flight, and then the captain will check it. So it just depends how you want to do it. Either pilot can do it. So let's start that now, and we talked about a little bit about this the other day. Right now, the menu page is what comes up when you first establish electrical power on the airplane. We're going to go to FMC, and that'll then come up with the ident page. You'll notice 10 minutes has elapsed, so the time to align says 0, and we get a message in the scratch pad saying enter IRS position. You notice the message light comes on here telling you have a CDU message, because it's trying to tell us, okay, the IRSs are ready, the IRUs are ready to accept a position, and we haven't put one in yet. So it's telling us enter IRS position, but we'll clear that out of there. We know that. And then we're going to go ahead and check our identification page. And we said we're going to check the model, 747-400 freighter. That's good. The engines, we're using the GE 2B1F engines. That's good. And we'll check that the active nav database is current. And today is January, 9th? And so that's current. There's two databases, active and inactive. And as time goes on, they'll put the new database and replace it, this inactive database, with a new database as we approach January 26th. And then we'll be able to swap it over at 0901 Zulu is when it takes effect. And we'd either change it if we saw that it needed to be changed, or maintenance would change it for us. Again, that's all we check. We don't care about nav data or drag fuel flow factor, operating program. Any of this stuff we don't care about. Next step is always right here in the pre-flight sequence, which is the pause and init page. We'll go to that. And we're going to put in our reference airport, which, if you look at your flight plan, is Boeing Field, KBFI. And when we put that in the dashes, it gives us a lat long for Boeing Field. This is the airport reference point, so it's kind of at the geographic center of the airport. You'll notice that we had dashes here for the reference airport. It means it's an optional entry. Whenever you see dashes, it means it's optional. You don't have to put anything in there, but you can if you want to optimize it. In this case, it's asking for a gate. Again, it's optional. You want to put a gate position in there, you can. We used to do this all the time at the airline that I was previously at. You used to put in a gate position, and we had coded gate positions, and we'd know where we are, and we'd look it up, and we'd say, okay, it's this code, and we'd put it in. And that was because we didn't have GPS in the airplanes that were early. And then later on, they added GPS. But once you have GPS, the position is very very accurate. And so you can use the GPS position for the set IRS position. So the gate we really don't need. Now, why do I put in the reference airport? Just for a reasonableness check. I'm just making sure this kind of agrees with this. I want to make sure that reference airport position more or less agrees with the GPS position. It's going to be off a little bit because this is very specific and this is very general. But you can see, you know, it's north 47, it's west 122, 31.8, 32.3, 18.1, 18.7. It's reasonable. So I know that GPS position is good based on the reference airport position. And I'm going to use that GPS position for the set IRS position. So I'll line select that to the scratch pad. And before I do that again, I'm going to go ahead and clear that. I would always make sure the scratch pad is empty before I line select something down to the scratch pad. So we go ahead and select that to the scratch pad, and then we can put it in the boxes. Now, boxes indicate that it's a mandatory entry. Anytime you see boxes, it means it's a required entry. And in this case, the IRUs need the GPS position in order to complete the alignment. We need to tell it exactly where it is. So we'll go ahead and put that in. When I put that in, you can expect that this is going to come to life because it's kind of waiting now for the PFD and the ND. So on your PFD, we don't see it here, but on your PFD, you would have, I could put it right here. That's CFOs. I can put it right here, and you can see it when I put that in. It'll enter the nav mode right away. So here we go, putting it in. And you'll notice after a couple seconds or so, you get attitude information, heading, speed, and you know, everything comes to kind of life here. And you notice the set IRS position blanks, and the last position now will become the GPS position. So you'll see it's 47.32.3, west 122.18.7, and that's the same as this. Now we'll check our UTC time, make sure it's correct. 18:05 Zulu, and that's let's see, 6 hours from yeah, so that's good. 18:05, and that's all we do here. We set the GPS position to the set IRS position. That can complete the alignment, and we check the UTC time, or Greenwich Mean Time, is correct. And again, I'll put the reference airport in just as a check that the GPS position is pretty good, and within reason that it's accurate. Next step in the pre-flight sequence is to go to R6, and that'll be the route page. When you go to the route page, you'll notice that you have origin and destination are boxes. That means it's a mandatory entry, so we have to enter something in there. So we're going to enter our origin airport from your flight plan, which is KBFI, Boeing Field. And when you put it in the boxes, it'll accept it. And then we're going to enter our destination, which is, in our case today, is a local IFR. So that's going to be also KBFI. Now I can type it out here, or I could line select this to the scratch pad, and I'll do that. And then line select the scratch pad up to the boxes for destination instead of typing it out. Anytime I can make a line selection versus typing it out, I'd rather do the line selection because it's prone to less error. So anytime I can do something without typing, I'd rather do that. So I'm going to put that in the destination line. So our origin is Boeing Field. Our destination is Boeing Field. Our flight number is going to be, we're going to call ourselves Sonic for subsonic. And we'll say our flight number for training is 44. So we'll put that flight number in. All that does is give pages kind of a title. If I go to the progress page, you'll see it says SO44 progress. It just kind of customizes it a little more for your flight. Company route we don't have, but if the airline had company routes, you could put in your code for your company route, and then it would put the whole routing in for you if it's a standardized routing. I don't know if most airlines have company routes. I tend to think not, because things change a lot. with ATC, and we found at the previous airline that I was at that the routings, if you had canned flight plans, a lot of times they would change. And so having a standardized company route, you'd have to end up modifying it anyway. So in order to make room in the database, they actually took out all the company routes. And then everything was either a manual route entry or in my time it was more of a manual route entry. Now, of course, you'd be able to send data link and to dispatch, and they can send you performance information and route information and things like that. So once we get to this point, we're going to go, notice it says page 1 of 2, we're going to go to page 2, because that's where we're going to enter the manual route. We don't have the ability to, in our case, for training, we want the students usually to enter the route manually and not request it from dispatch and performance and things like that. We want them to input the information. In LOE, if that's the way you do it on the line, that's the way you would probably do it in training too. So it depends whether you're doing, not LOE, but if you're doing AQP training. If you're doing AQP training, which is more advanced, it's line oriented, you would probably then, if you request performance through your dispatch, through the data link, you'd probably do it that way. But in the case where it's not AQP, it's traditional training, normally we would do manual route entry. And that's how we do it how we did it at Boeing. It was manual route entry. So we'll go ahead and put in the flight plan here. The flight plan was Orton, Oscar, Romeo, Tango, India, November. And where do we put that? Well, we always put it under 2, because the 2 line is for waypoints or nav aids. The VIA line would be for either Victor Airways, Jet Airways, any airways that are designated airways, or direct would be put under VIA. So in this case, we know Orton's a waypoint, so that's going to go on the right side. And when you put that in there, it says select desired waypoint. And actually, when you look at this, I don't know why they're asking you this, because it's the same point. There's no difference at all. So it doesn't matter which one we select, it's the same lat long. I'm not sure why that comes up like that, because it's not like you have 2 Orton waypoints, they're the same point. We can line select here or here, or here or here, it doesn't matter, it's the same point. So I'll select over here. And then that puts that lat long in there for Orton. And then after Orton is Vamps. And where's that going to go? Well, it's not going to go here because it's a waypoint. If I put it here, it'll automatically, the computer, assume that from Orton to Vamps, you want to go direct. There's no other way. It's a default. If you put a waypoint and a waypoint, it's going to say, okay, you can go from Orton to Vamps, it'll be direct. So when you put that in there, it automatically puts direct in there. Now, the legacy, it's a little slow, but it's not this slow. The Aeroinks kind of slowed this down too much, I think. It does, it's an older processor, very kind of old technology, and with a legacy. And so, yeah, there is a little delay, but it's not quite this bad. And the next waypoint after Vamps would be direct to Papa Alpha Echo, which is a Paine VOR. And again, I put it after Vamps. And if I put it after Vamps, it's going to assume you want to go direct. See, that should be in there already. That's way too long. Now it says select desired waypoint. Now this is more accurate. So we do have 2 different, well actually 3 different Papa Alpha Echoes. And it's asking us which one do you want. Usually it's the first one. Not necessarily, but that's usually the case because that's the closest PAE to you. And in this case, just glancing at it, you can see that this is north and west, and I know I'm in the northern hemisphere, and I know I'm at west longitude. This one's in the southern hemisphere, I know I'm not there. And this one's in the northern hemisphere, but it's in east longitude, so I know I'm not there. So just kind of eyeballing it as well, you can see that it's this point and not this or this, because these are in different parts of the world. You do have to be careful and make sure you select the right one. The one you normally want is the first one, but you can't assume that. You still have to kind of check the lat longs and make sure you select the proper one. So in this case, I can select here or here, it doesn't matter. And now pain is in there. And then after pain, we're going to go Victor 23. And Victor 23 would go on the left side because that is a low altitude airway. The jet airways would be a J, and of course internationally there'd be different designations for the airway. But airways always go on the left side, waypoints or nav aids on the right side. And notice when you put in Victor 23, it took it. Now I know by the fact that it took it that pain joins up with Victor 23. Because if it didn't, it would have said invalid entry. If I tried to put something else in there, like let's try to put Victor 4 in there, it's going to tell me that that doesn't join up with pain. That doesn't join up with this VOR. So the fact that it took it means it does join up with that Papa Alpha Echo VOR. And then after Victor 23, we want to go to Seattle. And same thing here. That's got to be a valid waypoint, otherwise it won't take it. In this case, it does take it. You'll notice on the ND here, and we'll step through the route here in a little bit, but notice it's a blue dash line indicating that it's an inactive route. Coming off of Boeing Field, this is, I won't change the range yet, but down here is Orton, this is Vamps, up here is Payne, and then Victor 23 to Seattle would be this line right here. But a blue dash line would signify it's an inactive route, which it is. There's nothing in front of route here. It says route 1. It doesn't say active route 1. Now the next thing I could do is, if I know my runway or I anticipate what my runway is, I could put that in. I like to use the departure page to do that and not type it out. So when I go depart, it's going to take me to the index because it doesn't know where I want to go. I need to tell it. Well, for route 1, I want Boeing Field departures. So I'm going to select L1 here, and that'll take me to the Boeing Field departure page. And then from there, I can select my runway, which is going to be 14 right. Now that's as opposed to coming here and typing it out. Now I could do that. There's nothing wrong with that, doing this. But again, this is more prone to error, typing it out. So generally, if I can go somewhere and find it, I'm going to go find it and select it rather than typing it out. So I'd rather go depart, departures, and select runway 14 right. And you'll notice if I go back to the route page, the runway's in there. If I go to page 2, you'll notice that there's dashes here and then Orton. So generally, if I put in the waypoint first and then I put in the runway, it will always default to dashes, meaning there's no connection between the runway and your first point. And that's kind of how I want it, especially if I'm going to fly runway heading radar vectors for Orton, let's say. In that case, I wouldn't want a magenta line going from the runway to Orton. Now, it doesn't hurt anything if it's there because you can always modify it. But to be clean, I want to enter the route first and then the runway later, because that will always make it so that I get dashes here instead of direct, from the runway direct to Orton. Again, is it a problem if you have a line from the runway direct to Orton, coming out here or wherever Orton is, down here somewhere? No, that's not a problem. But to be cleaner, I'd rather have no connection between the runway and the first point, because then I'm going to fly runway heading at 400 feet, push heading select. He gives me turns, he gives me vectors, and then he says, okay, you're clear, direct to Orton. Then I put in Orton, and now I get my magenta line after I execute it, direct to Orton. But right now it's cleaner to put the route in first and then the runway and leave this dashes. Again, you can do it either way, but this is a cleaner way of doing it. So then we're going to go ahead and if that's complete, and again, I could put in the Ken 8 right now, but I'm going to wait till we get the clearance, and that'll be part of the clearance. So once I have the route in, I can go ahead and activate it because this still is an inactive route. If I activate it, we'll get the execute light, we get an erase prompt, and notice there's a white dash line on top of the blue dash line now because it's a modification to the route. We're proposing to make it active now. And if that's what I want, I could go ahead and execute that. Now, do I have to get permission from the other guy to execute this? No, not right now, because we're just doing the CDU pre-flight. And he's going to check it. The other guy's going to check it. So when they go through their CDU pre-flight, they're going to be checking all this stuff. So I don't need to wait for execution from that other crew member at this point. I can just go ahead and execute it. When I execute it, the execute light extinguishes, the erase prompt goes away. And then we'll see active here for active route 1, and you'll notice this turns magenta then. The blue lines and the white dash line will turn magenta. So I'll go ahead and execute it. You notice the execute light extinguishes, erase prompt goes away. We have active route 1, the route is now active, and this turns magenta. So now we have an active route. Now the next step in the pre-flight sequence is to go to perf init. So I'll go to Performance Initialization page, R6, and now we've got a bunch of boxes here. So we need to put in this information. So the planned zero fuel weight, if you look at your paperwork, the planned zero fuel weight is 480,000 pounds. The preliminary, we could always update that if it changes, but that's the preliminary number we have in our package, in our flight package. And so we'd have an idea of what we're going to carry that day, but we're not sure of exactly what the final number is going to be. But we can put that in now. Usually this will say calculated, not sensed. It'll usually say CALC. Sensed would mean it's coming from the sensors in the tank, and it's being sensed directly from the tank. And that's not the case. It's usually calculated fuel, which means it'll be calculated when you go to run on the fuel control switch. The number that you're seeing there will be the fuel used based on fuel flow and the engine's running, and not the total in the tanks. And then there's a comparison between the total in the tanks versus the calculated fuel, which is dependent just on fuel flow. But right now this would say calculated, and usually you can change this, but I can't change it. A lot of times if you put in a manual entry, like you put anything in here, and you do that, that usually goes to manual. And then you can delete that manual entry and it would say calculated, but I can't do it on the Aerowings. So see, I should be able to put any figure in here. And then it'll say manual. And then I could go ahead and delete that manual entry and it should say calculated, but I can't do it here. So I just leave it sensed. I'm not sure how you get it to calculated. I'll leave it sensed. It'll go to calculated probably when we bring the fuel control switch to run. We'll check it and see if it goes to calculated. Reserves will be, let me see what the reserves are. Reserves are 20,000. So you'll notice this is box, 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 decimal 0. So we put it in as a function of thousands of pounds. So in this case, 20 would represent 20,000 pounds. I could put the 0.0, but I don't need to. If I put that in there, it'll just take it as 20.0. Cost index we're using today is, what is it? What do we use? 125. So we'll put cost index in here. Boxes take it. Cruise altitude, we're saying it's going to be 9,000. So we can put 9,000 in here. Now, how do we put 9,000 in there? I can do it one of two ways. I can either put 9000, that works. Or I could put 090, that'll work. But the one thing I can't do is put 90. That doesn't work. If I try to put that in, notice this says invalid entry. So I think in the 737 you can do this. That's why I'm mentioning that. But in this airplane you can't. So you'd have to put in, most people would just put in 9000 and then put that up there at the boxes, 9,000. And looking back to see if there's any questions. No questions, okay. I'll pause for a second here and see if anybody has any questions after we're done with the CDU pre-flight. Step size is ICAO. ICAO is, we used to leave it in ICAO quite a bit because ICAO would be 4,000 foot steps. I can't remember what ICAO was now. It was, it might have been 2,000 foot steps up to flight level 290, and then above 290 was 4,000 foot steps, I think. But with RVSM airspace today, everything's pretty much, step size is usually we'd put it at 2,000 foot increments and change that ICAO. So I think with ICAO is 2,000 foot steps up to 290, and then it would automatically default to 4,000 foot steps above 290. But because of RVSM, we put it at 2,000 feet, and that's probably more realistic for the RVSM airspace. So we're done here. Cruise CG, don't touch that. Some people will think that's some people will mistakenly put their CG in here. You got to read it. It says cruise CG. That really doesn't matter to us. Just leave it small font, and we'll go to the thrust limit page. We're going to use full TO and full climb today, so that's already set. That's the default. Outside air temperature is 15. That matches with the ATIS. Next step is to go to the takeoff page. And now we want to put our flap and acceleration height. So we're going to use flap 10. We'll say our performance indicates that we're going to use flaps 10. And the acceleration height will be 1,000. Now I wouldn't have to type this out, but I want to type it out because I want to make it big here. It just stands out more. So I'll put 10/1000. And then that's big now. Now that's the only box that it needs. But engine out acceleration, we're going to change that because it's not 400. It's probably either going to be 800 or 1,000. We're going to use 1,000. Thrust reduction is going to be flaps 5 for today. That's the NADP2 that we talked about. But again, I want to make it big just so it stands out. So I'll put 5 in there and line select it to thrust reduction. That just makes it big. It really stands out for you. And then wind and slope. We're not going to worry about that. If you had a tailwind or a downslope, we'd want to put that in because that would have a performance decrease. A headwind and an upslope would give us actually in our benefit. So by not putting anything in for a headwind or upslope, you're actually more conservative. So generally we don't put anything in here. You could, but especially if it's a tailwind or a downslope, you'd have to. Runway conditions dry, and here's our V speeds and our CG. Now we'll leave these small font, we'll leave the CG out because we're not sure what the final paperwork shows. And we may have to modify that, so we'll just leave it like this. You'll notice that there's dashes here, and it says thrust limit. That tells you the pre-flight's complete. If the pre-flight was not complete, like we saw the other day, it would say pre-flight, and then it would have the page that's not complete. But in this case, we know it's complete because we have dashes and it says thrust limit. So everything's been done, but we don't have our V-speeds activated. We haven't put our CG in for the trim, and that's because we don't have our final numbers yet. Okay, next we're going to go to the, that completes the CDU pre-flight. So now if I'm the first officer, I'm going to go to the CDU, or sorry, the overhead panel, and do the first officer scan flow. Okay, so let me look back at the questions here. Should the nav light be turned on? We answered that one. There's also the flight, we talked about that flight deck access light. Which ACARS procedure has to be done, Walter says. Yeah, the ACARS procedure would generally come at some point where you're going to put in your IDs and your, because it's going to want to record your time out and off and in landing and at the gate. And so the company needs to know that information. But generally, we are going to not put anything in for ACARS when you're training. It's just what we do. We don't normally use ACARS for training. And like I said, for AQP, I think even AQP sometimes they don't, because it just wastes a lot of time. And you're not really communicating with a company at that point. And so a lot of times they may go over it once how to put that information in, but then they'll go over it in LOE or in SOE, supervised operating experience, when you're on the line. And they'll do it that way. So ACARS we're not going to worry about because it just takes up unwanted time. Let's see. And Walter says 2000. Yeah, on the NGFMC, it usually says RVSM. I think it usually defaults to RVSM. But if it didn't, you could put R in, and it would then change it to RVSM. And then do you put in the winds later? Yeah, normally if we had a real flight plan, we're going to probably put in enough winds to get started, and then we'll put the rest of them in later if we don't have data link. Now, the nice way to do it is just to request the winds from dispatch, and then they'll data link those winds, they'll uplink those to you, and then it's automatic. And, again, in previous years where you didn't have the data link system to work with, you had to put in the winds yourself. And then you would just put in enough winds to get started. Then when you get airborne, you got plenty of time to put in the rest of the winds. Now in training, again, we don't normally put in the winds because we don't have a real flight plan. However, there's one lesson, I think, here in the FTD where we do talk about the waypoint wind page, and we put in some winds and we talk about that page a little bit, just so they're familiar with it. And then when they get on the line, they would actually then either manually put in the winds up to a certain point, enough in front of you that you can do it when you're up to your cruise altitude and on your way. Then you'll put in the rest of the winds, or we would just, the easy way, of course, is to request it, data link it, request it from dispatch, and boom, there's your winds. They'll come to you, and they're all in there. And that's the way it's mainly done today. Most people have that capability today. And we'll probably look at that later on. Any questions other than that? CDU pre-flight. Again, when you're training, you're not really, your procedures training, right? You're not going from point A to point B. And route 2 you can put in, you can copy the route into route 2. And that way you have it in there if something changes, that our original route would be in there. So yeah, we'd normally copy route 1 into route 2. And we show them how to do that. I'll do that when we do the CDU, when the other guy checks the CDU. I'll look at that and put that in. So let's look at the overhead panel. Now the FO does his overhead panel. So here's what we're going to do. We're going to make sure the ELT switch is armed, which it is. The guard is kind of closed, and the switch is in the middle position, which is armed. The EEC switches should be in normal, and the alternate light should be extinguished. The IRUs are in nav, which they are. And now we'll check electrical. Standby should be in auto. The utility buses are on. The off lights are extinguished. Here's a good point where we could start the EPU. We could start it sooner if we needed it. But again, in training, we usually start at this point. So we'll bring it to on, and then we'll go to start and just hold it there for a second, and then release it to on. And again, normally if our hand was there, we would make sure it doesn't spring back to the on position. And then that'll start the EPU. Do you have to monitor it? No. You don't have to monitor the EPU. It's got an EPU controller, and if it needs to shut down for any reason, it will do it automatically. There's nothing you need to monitor here. You're just waiting for the available lights to illuminate, indicating the frequency and voltage are good for the EPU1 and EPU2. And there they are already. Started up pretty fast. So now if we wanted to, down here, we could switch over to the APU. We always want to switch over to the APU well ahead of when we actually start engines, just so if there's any spurious status messages that would show up as a result of transferring power, we'd have plenty of time to address them. So we don't want to kind of wait till the last minute before we switch to the APU. And we'll do that now. We'll go to APU1. And again, I can go to APU2 as well, because external 2 is still available, and external 2 would power the main cargo handling bus. So if I'm a freighter, I'm still okay. I can go APU2, I can bring it on, and as long as they don't pull external, we're okay. Now if they finish loading, they can certainly pull external, it's not a problem. But at this point, if they're still loading, we'd want to make sure that main cargo handling bus is still powered. Bus tie switches are auto, the isolation lights are extinguished, generator control switches are on, the off lights are illuminated, the drive disconnect switches are guards closed, they're wired, and you check that the drive light is illuminated. System fault lights would all be illuminated. Demand pump pressure lights would all be illuminated. Demand pumps should be off. And the engine driven pumps are all on, and the pressure lights are all illuminated. Now you'll notice that from the bus tie switches up, there are no lights, except for these lights, except for available lights and on lights and for the APU and external. But otherwise you'll notice there's no lights, no lights, no lights, no lights. There's no lights. From the generator switches on down, there's all lights. Off lights, drive lights, system fault lights, pressure lights, pressure lights. So really, at a quick glance, you can see from the bus tie switches up, no lights. From the bus tie switches down, all lights, system status lights. Now remember, when you check these switches, you're checking switch position and light indication. Okay, not all switches have lights, but if they do have a light, you're checking that the light indication is proper. So with an alternate action switch like this, like the generator control switch, we're checking that the switch is on and the off light is illuminated, and that's how it should be. Here we're checking the switch is in auto, which means it's pushed on. It's an alternate action switch, and the isolation light is extinguished. So we're checking two things here. This switch is a momentary action switch, external power, APU, because when you push it, it makes contact, but then it comes right back out. With an alternate action switch, you can push it off and you can push it on. When you push it off, there's a little shutter that will cover the symbol on and indicate the switch is off. And in this case, the off light is still illuminated because the generator breaker is open. But the switch itself is off. If you bring it back on, you'll notice there's a little shutter that kind of comes up and disappears, and it displays the on indication. And so this is called an alternate action switch. This is called a momentary action switch. These are called rotary switches. These are called toggle switches. And those are the main switches that you have. You either have rotary or toggle, or alternate action or momentary action switches in the airplane. So again, just a glance here can tell you that all lights from here down, no lights from here up, and that looks good. Now that's not all you want to do, but what I'm saying is a final check when you go through this, you can just kind of look at it again and say, yeah, there's all lights there and there's no lights there. That's right. That's correct. Lighting we already talked about. We adjusted all these. Fire overheat test, and notice we go from top to bottom and then top to bottom. Could you go top to bottom and bottom to top? Yeah, you could, but it's deviating from the way the manual says to do it. And again, generally we discourage that, at least when you're learning, because we want you to do it the way the book says to do it. And that's the reason for it, is that, is it wrong if you went here to here? No, not if you check everything. And some airlines do it like this. They change it to this, where they go top to bottom and bottom to top, because it's like an S, just keeps flowing. So a lot of people like this, it just keeps flowing. Whereas up to down, up to down, up to down, it's more disjointed. It's up to the airline, if they want to change it or not. But the Boeing way is up to down, up to down, up to down. Fire overheat test. This is primarily a maintenance function. When you push it, you'll get all the fire lights illuminate. The fire bell goes off. All your lights come on the overhead panel. If we were to move to the lower panel, you'd see the fuel control switches all illuminated. And on the ICAS, you get a fire test in progress, and then it would say fire test pass or fire test fail. Again, normally we don't do this, because when you do that, it'll also set off a fire alarm in the body gear wheel well. And in some cases, if the crew were to do it, and in maintenance or the ramp personnel would have to be advised that, hey, if you hear a fire bell that's just for a little bit, it's the crew doing the fire test. But again, we don't like to do that because we don't want fire bells going out in the body gear wheel well. So generally, that's a maintenance function to check that, and they normally check it. Emergency lights, we'd close the guard. When you close the guard, there's a little clip here. That clip kind of will, when you bring the guard closed, the clip will pull the switch into the arm position automatically. So you don't have to put this in armed and then close the guard. You can just close the guard. And when you do, if you bring the guard open again, you'll notice the switch is in the arm position, because that clip, that little mechanical clip, pulled it down to armed. Captain audio system normal, observer audio system normal. Interphone off for the service interphone, the cabin, cargo cabin interphone off. Main transfer 1 and 4 should be blank. No light indication. This one's I think it's a momentary. Is it a momentary action switch, or no? It's an alternate action switch. Now you'll notice something about this switch. It's got a guard, but see this little white line right here? This little white line tells you don't expect to see a system status light on this switch. It is an alternate action switch, but there's no system status light associated with it, so they draw a little white line here. And that tells you, like here in the outflow valves, you see this is alternate action too, but there's no light associated with it. You can go to manual or you can go to auto, but there's no light that's telling you something. So they put a little white line there telling you don't expect to see a system status light on this switch. You can see a bunch of them have it. Here, here, here. Zone reset here. High flow here. Aft cargo doesn't. But you can see the switches that don't have that will have system status lights. Like you can see if I turn on window heat, notice there's no line here. There's no white line there, because we do expect to see a light. If I go to off, the in-op light comes on, illuminates. So that's what that means. That little white line means don't expect to see a system status light there on that switch. Doesn't have one. Fire switches, we'd push them in. We physically push them in just to make sure they are in. Same thing with the APU. We just kind of take our hand up there and push it just to make sure it is in. Discrete lights should all be extinguished. This is the cockpit area microphone. Switches all off, lights should be all extinguished. Guard closed, the lights extinguished. Start switches should all be in. We'd push them in just to make sure they're in. Standby ignition selector should be normal. Continuous ignition should be off. And auto ignition selector should be single. This can vary depending on what your airplane is. It could say 1, both, and 2 for igniter 1, igniter 2, or both. Or it could be single, meaning a single igniter, either 1 or 2, and both igniters. So they could look a little different depending on your option. Auto start switch should be on if you're using it, and it works. Fuel jettison should be off, and the nozzle valve switches should be guards closed, and no lights illuminated. We don't put a fuel to remain in there. Some airlines do, we don't. Again, Boeing procedure, that's what we're using. Fuel system, we'd want to make sure all the cross feed valves are open. And so in this case, if it came in and it was tank to engine, 1 and 4 would be closed. So we would just want to make sure we open these. These should never be closed anyway. But again, we're just making sure we see the flow bar, flow bar, flow bar, flow bar, flow bar. All of them are open at this point. We want to make sure all the fuel pump switches are off, which they are. And we want to make sure the pressure lights are illuminated for the main tanks, and the pressure lights would be inhibited for the center tank, for the overrides. And in this case, the APU is running, so the APU is using the main 2 aft pump. Now in some airplanes, it's tanks 2 and 3, so you'd see a pressure light extinguished here as well. But in this configuration we have right now in the Aerowinks, it's just tank 2 that's providing the fuel for the APU via AC. So again, you could see 2 blank indications, one here and one here, depending on the your airplane. Or you could see just one like you see here. The older airplanes always had this, just one. The newer airplanes have 2 and 3 would be extinguished, and the APU fuel would be being used by 2 and 3, and not just 2. So that's what we check for here. All cross feeds open, all fuel pumps off, and pressure lights in main tanks 1, 2, 3, and 4. The rest of them should be blank, blank, blank. And what's the APU using? It's using main tank 2 in this case, or main tank 3. Nacelle anti-ice should be in auto. And again, you could have push button switches here. It depends on your configuration. These are the toggle switches, but you could have on-off switches that would look just like an alternate action switch, where you turn on and turn off the nacelle anti-ice. This automatically will turn it on or off when you have it in the auto position. Wing anti-ice and auto. Window heat, we'll turn that on now. That should get rid of those status messages. Wipers, again, just check that they're off. Washer fluid should be off. These are spring-loaded anyway, so they should be in the off position. Lights, we'll just make sure our landing lights are all off. Turn-off lights are off, and taxi light is off. Come up here, supernumerary guard closed. That'll put it in the normal position. Yaw damper switches are on, and the light should be extinguished. You would see the light if the IRU, if we hadn't completed the alignment process, then you would get an off light here in the until the IRSs are aligned, and then the off light would extinguish. Usually we get an off light there. See if it comes on. Maybe it's just taking a while. You should see an off light here. No, well, maybe not, because the IRUs are aligned at this point. No, you wouldn't see it now. But you could see on, off, off if the IRUs are not aligned yet. And sometimes when you go through your cockpit setup, you might get here before the IRUs are aligned. And you'll see off, off, and that's normal because they aren't aligned. But once they enter the nav mode, these should extinguish. And then they're ready to go, except, and the reason you don't see the off light here is because these things are ready to go. but they're not operating yet because they require you to be airborne and they require hydraulic power. So until those two conditions are met, the yaw dampers will not be working. Right now they're good to be, they're armed to be working, but they're not going to work till you're airborne and you have hydraulics. And then if they didn't work, you'd get the light here and you get an ICAS message. Landing altitude should be in auto. You could push it on to go to manual. And this switch could look different as well, depending on your airplane. This is a push button switch where you push it, it'll go to manual, and then you can rotate it and set your landing altitude manually. In some airplanes, it's just a, like the map light, it's a pull it off or pull it out, and that would put it in manual and then rotate it. And you won't have this push button. So it really depends. And you see down here in the, you can see down here you have auto. And you can see if I come up here and I push this, then that'll take it to manual. And now you're setting the landing altitude manually and not having the FMC set it automatically, which it can do. I'll go back up there and push it again. And then that should restore it back to auto, which you see here. Outflow valve should be open. The manual switches should be off, so it's in auto. This is spring loaded to the middle position. If you go open or close, it's going to spring right back to the middle position. And the auto selector should be in norm, and then it selects A, B, A or B on an alternating flight basis. We're in a freighter, so the fan, that'd be optional. You could have it on now if the cockpit's stuffy. You could work it on, it only works on the ground. If not, off. Temperature selectors should all be pretty much in the 12 o'clock position. You get to know your airplane, maybe it's an 11 or 1 or whatever works. You know after a while what you need to put. But generally is a place to start. They should all be in 12 o'clock. Zone reset should be out. This is a momentary action switch, so it's out. And notice again, here's a distinction too. Momentary action switches have the line on the top because they're telling you don't expect to see an on indication when you push this switch and that it latches on. It doesn't. You'll notice if I push it, it just goes in and it comes right back out. In and out, in and out. It doesn't stay on like this one would. If I take trim air and I turn that off, it's off. If I turn it on, it's on. And you'll notice there's no system light for trim air, and there's no on indication for zone reset. If I turn trim air off, yeah, you get that light. If I turn trim air on, that light goes out. But again, this means there's no system status light. This means there's no on indication. It's momentary action. 12 o'clock, they're good for all these. Equipment cooling normal. High flow off. Aft cargo heat off. Packs, we can turn them on. We could have turned them on before this if we wanted to, if we needed air. But we'll turn them on now. Pack reset, we check to make sure that's, again, no light. Again, no on. There's no on and off switch. It's just a momentary action switch. But there is a light, and we would expect to see that light extinguished at this point. Packs are on, isolation valves are open. And again, if anytime you're going through this yourself, take the switch and turn it off to see what it says. A valve light, and if you turn it, the isolation valve back on, the flow bar would illuminate. The valve would momentarily show that it's in transit, and then it would extinguish. And so you're checking that both isolation switches are on, meaning the flow bar is showing, and the what was that light again? The valve light would show that it's the valve light should be extinguished. The only time you see that valve light is when it's in transit or if it's stuck somehow. APU should be on, and again, no light indication. The system fault lights here should be extinguished. And the engine bleed should be on, and the off lights should be illuminated. Because an engine's not running now, and so the PRV and the HP and the LP valves are all closed. Lighting, we could come down here and check that the beacon's off, the nav should be on, the strobes are off, the wing's off, the logo's off, and the indicator lights we could do a test. Again, this is usually maintenance does this, but if we wanted to do a test, we could. You press it, you hold it, and the lights will go to bright initially, and then after about 8 to 10 seconds, they go to dim. And you could check all your lights all the way through the panel. We won't do that. And then and your radios would say 8s, and you know, you do that yourself if you want to see that. We'll leave them on bright. And then that's it for the overhead panel. So it's top to bottom, top to bottom, top to bottom. And now where do we go from here? This is where you have to kind of link to somewhere. And where we want to link to is we want to link to the flight director switch for the FO. Because remember, this is all the FO scan flow. So now we're going to come down here and turn our flight director on. That's where we kind of link to. Just remember flight director from the overhead panel. And then ICAS select panel will be as desired for right now. You could probably go, you know, doors. We'll see, you know, maybe you see doors open. We're going to go to engine when we check the ICAS. But for right now, this would probably be as desired. I want my ICAS messages displayed for now, so if they're not, if for some reason I canceled them, I want to push recall to make sure they're back up there, because I'm going to check them. That's about it for that. Then I come to the EFIS control panel. I want to be in baro, not radio. I'm in the States, so I want to be in inches. Flight path vector, that's up to you whether you want it on your PFD or off. Yeah, some people like it, some people don't care. Or they may turn it on in flight and leave it off for takeoff, but they'll turn it on in flight. That's what I'm more in that camp. Meters would be, you know, if you're in China or Russia, then you're going to want meters versus feet. We'll be in VOR, and I'd probably put one to ADF. This is what we do at Boeing normally. VOR, ADF, just to check them. We'll be in map mode, and we'll be in the whatever range we want to be in. We'll stay in the 20-mile range. And then if we know our altimeter setting, we could set it. And for the ATIS, it says 2992. So we'll go ahead and set that now, because I know what my ATIS is, so I'll set it to 2992. And then we could leave that like that. We'd probably bring the airport on, because I'd want that on. I don't, again, it's technique, but those show the airports in the database that have a pretty usable runway in case we need to land. Not necessarily suitable in terms of airline facilities, but could be very suitable in terms of landing the airplane if you had an emergency. So that kind of brings on all the airports in the database that have a certain runway length that's hard surfaced. And again, it varies on the airline what they set it to. They could have it set to 7,000, 8,000, 9,000, whatever they decide to set it to. I think I have it set to, 8,000. So we show all the airplanes in the database for your selected range that are in the database, and kind of gives you an awareness of where the airports are if you have a problem. So I'd make sure that's on. Also, this is in the full 360 compass rose, so I don't want to put that in the expanded mode. I don't want to leave it in the 360 mode. And again, if push it once, that's the full 360 mode. Push it again, it's expanded mode. I also want to see TCAS off displayed, so while I'm here, and if the IRUs are aligned, which they are, I could check that traffic that I see TCAS off. If I didn't see it and we're aligned, then I'd want to push traffic and see TCAS off. I want to check that it says TCAS off. And that way the TCAS system is on when we go to RATA. And that's about it up here. I'd probably go back to, I checked this VOR is green, ADF is blue. We're not tuning anything right now. And then I'd probably bring this one back to VOR. VOR left, VOR right. Then from here I go down to my, I could run through lighting if I wanted to right here. We set that already. And then I'll come down to my oxygen panel, which I can't really check in the AeroWinks. They don't, in PMDG it has it, but in AeroWinks I can't really check it. But basically I'm checking that the oxygen is in 100%. The little red toggle switch is pushed down. And I'll show you this when we do the -8 differences. But the door should be closed of the oxygen mask. The little red toggle switch should be on 100%. And then normally we'll do a couple of different checks. We'll check we'll hold the reset test lever down and see the yellow cross momentarily indicating oxygen is flowing. And then at the same time we'll hold the reset test lever down and then push the emergency switch, little red button, and hear the sound of oxygen continuously. And then if I'm on the status page, and let me go down here, and if I select flight and speaker, and I'm on status, then what I could do is I could take as I'm holding the reset test lever down and holding the emergency button down and hearing the sound of oxygen continuously, I would check that my PSI for my crew oxygen pressure doesn't drop significantly, or more than 100 psi, I think is what they say. More than 100 psi. It doesn't drop. So I'm checking that, and I'm holding it for 10 seconds to make sure this doesn't drop off to nothing, because then I might have a leak. So by checking it for 10 seconds, it should stay, 1880, 1870, 1860, but I shouldn't see it drop more than 100 psi. While I'm doing that, I could then come to my, since I have this in flight and this in speaker, I can check the oxygen mask microphone by going to my push to talk switch. I'll do it here instead of you could do it up here on the dash, but I'll do it down here. So you could bring this to the RT position, and then you would hear the sound of oxygen flowing across the oxygen mask microphone. If you do the microphone check. Some airlines do, some airlines don't. So we'll show you this more when we do the -8. But so there's a couple things you'd be checking. Doors closed, normal 100%, switching 100%. The reset test lever, you'd pull down, see the yellow cross. You'd do it again, pull it down, push the emergency button, hear the sound of oxygen continuously, and the yellow oxygen flow would be on continuously. You'd see the yellow in the window. And then we'd come over here to our status page and check that we'd hold it for 10 seconds and make sure this doesn't drop by more than 100 psi. And then if we wanted to, if our airline as a matter of course does it, we'd be in flight and speaker, and we could go to RT, and then we hear you'd hear the sound of oxygen across the oxygen mask microphone and over the speaker. So that's describing it without doing it. Let me get this positioned again. We'd also check the foot and shoulder heaters as desired. Normally they're going to be off, but you could use, I think the foot heaters you can use on the ground if you wanted to, but shoulder, no. We'll just check to make sure they're off. And then instrument source select switches should be all 12 o'clock. Usually they're auto. In this case, the IRS doesn't have the auto position. I could change it through the options here to make it have auto. Most operators have auto, so it'll say auto, and then right, center, and left. So it'd be auto, and then FMC right and flight director right. In this case, it has the paravisual display too, which would be right. Where this is the right flight control computer, right FCC. This would be the EIU, EFIS ICAS interface unit, which is normally right when it's an auto, and then it'll switch to center or left if it fails. And then this would normally be auto too, but some airlines might have this switch where it doesn't change automatically. And then air data would be auto. So usually you're checking auto, everything 12 o'clock, 12, 12, 12, 12, 12. And then I'd come here to my clock, make sure the, right now the elapsed time is running, so I want to blank that out. So I can just go to the hold position for elapsed time, and then I can reset that. And then that'll blank this window. And then when I want to start my elapsed time, I can go to the run position. And then that'll start the elapsed time. Like on takeoff, when you want to keep track of the elapsed time from the time you take off to the time you land. You go to run, and then clearing it out would be just to go to hold and then back to reset. Time is on GMT. We could set it. We won't talk about setting the clock for right now. Date, chronograph. You can check the chronograph by pushing again, stops it. Push again, it resets it. It's also up here. You have a clock switch up here too that push starts the chronograph. We'll count in seconds, and then when it gets to a minute, it'll say a minute, and it'll count to 2 minutes and 3 minutes, and so that's the chronograph function. But right now we're just making sure we have GMT time. We're in hold for the elapsed time. We're in run for the clock, and you can check if the chronograph works. Then we're going to bring the from the here. We're going to go ahead and check our PFD. Now we do stop here if the IRUs are not aligned. Like if you're fast and you are checking everything. That's assuming you're fast and you're accurate. we don't want to be fast and not accurate. So, but if you're fast and accurate, you might get here and the IRUs are still not aligned. And in that case, you can't continue because you got to wait till this is up before you check it. We can't check it when it's nothing's there. So normally I'd pause here if the IRUs are not aligned. Now they are aligned, so we can go ahead and continue. Blank Toga FD. We're checking 8 degrees pitch up, wings level. You notice the pitch is up around 8 and wings level. No V speeds because we have no V speeds there. The ground speed's 0. Our heading should be the same as the track right now. Our altimeter set at 2992. We have 20 feet showing. That's good. Notice anything magenta is what you have set on the mode control panel. So right now we have 200, north, and 10,000. And that's what comes up when the airplane's unpowered. Anytime the airplane is unpowered, it will normally come up in the 200 north and lost my train of thought. 200 north and 10,000. So that's the default, when you're unpowered. And then we're going to change them from there. Again, once you check everything here, your just basic thing is you're checking that there's no flags. But we do want to check that we have blank Toga because we have something else. Like let's say we have, let's say it shows this. Okay, well somebody did something maybe up here to push heading select, maybe inadvertently, but it doesn't say Toga. So I'm going to want to go ahead and reset the flight directors in order to get rid of that. So you can see the captain hasn't turned his on yet because we haven't done the captain's scan flow yet. But if that was on like this, then you'd have to turn both of these off in order to recycle them and then back on again. And then that will recycle back to the back to blank Toga. Notice the green attention box around there for 10 seconds telling you it's a new mode. And so that's why you want to check it. You want to check that the indications are correct. You just don't want to look at this and say, well, there's no flags, it's good. It's blank Toga FD, 8 degrees pitch up, wings level. And again, you can check your magenta indications if you want for what's set. We should see 30 knots parked, the ground speed 0, -8 on the radar altimeter, And the heading will be the same as the track right now. And again, no flags on this whole display. You can check your instrument selectors up here. They should be in norm for your inboard CRT and lower CRT. And then for the ND, same thing. You're going to check mainly that there's no flags. But we're going to check ground speed 0. We'll make sure TCAS off is displayed. We want to see that. Again, if it wasn't displayed and the IRUs are aligned, which they should be if you're checking this ND, then you can come up here and push traffic and you'll see TCAS off. We're in VOR, that's fine. Again, heading and track are the same right now at 332. We're in magnetic. We have an active route because it shows magenta. And the main thing is on this display there's no flag showing. Again, our map switches up here are set to, we have one on, and that's the airport. And that's just, again, that's technique, that's preference. Depending on what you want on. You might want data on too, but I'll just say we want the airport for now. And then I think the Boeing procedure kind of goes, it's a little bit different here where it goes, I think, from the flight instruments and it goes over here. And it goes like this. It kind of checks here to here to here. Now, is it wrong if you went, if you did check this and you went like after the ND, you come down here and check this, and then you go this way, and up this way, and over that way? No, that's not. Again, it's not exactly how it's written, but you're checking everything. I think it flows better. Personally, I like it better when you do this. When you go down here, and then I can just come right here and check terrain override, guards closed and no indications that it's on. Gear override, same thing. You notice again, we got the little line down there saying, don't expect to see a system status light here. All you're going to see is in this case, override, but there's no light indication. So these should all be switches off. Glide slope inhibit, that's a momentary action switch. That should be out and dark. Wing, nose, and body, again, same thing. See, here's the little line again, no system status light. But they do have an indication when you turn them on. Gears down, it's green. The alternate flap, again, we're checking it again that it's off, and the arm switch is off. And then we can check that we're in left FMC, the heading reference is normal, the EIU is auto, and the brightness we've already talked about and already set. Now again, you could come here and do it the way the book's written and go to here and across this way, down this way, and down that way. Technically, that's the more proper way to do it. Again, if I saw a guy do it this way, is it wrong? No, he's checking everything. And this is not that big an area that he changed the flow a little bit. So that's where it says in the FCOM that you can modify the scan flow a little bit as long as you're checking everything. Now, if you want to be a real hard ass about it, then you got to do it the way the book is. Well, that's fine to a certain degree. But if it's something like this where you just go this way instead, you're still checking everything, and I wouldn't have a problem with that myself. As long as he's checking everything. Then you get to here. Captain Marco's in the building. Hey, Captain Marco, UPS captain right there. He's got good YouTube videos if you want to see. Look up Captain Marco. He's got some good videos on YouTube. If you come here and you check, once you're done with this, and again, if we did it by the book, it'd be this way. Then we can come to the ICAS. And with the ICAS, we're checking to make sure that these messages are all normal messages. And so we want to kind of cancel these. We kind of want to look through them and make sure they're normal. Engine shutdown messages are normal. The nose cargo door is open, that's normal. The door aft cargo is open, that's normal. They're loading still, the airplane, so that's okay. Brake source, there's no active brake source, so that's normal. Barrow disagree, well, maybe the captain didn't set his yet. I can look over and see, and sure enough, he didn't set his yet. I set mine to 2992, so that's why that's displayed. We're going to expect to see fuel pumps off, and all these fuel pumps are off. We're going to expect to see that. There's some more, actually all the doors are open here. Which normally wouldn't be the case, but we've got everything open. More doors are open, that's fine. Fuel pumps, again, cancel. Fuel pumps, yeah, cancel. Okay, but if there's something here I don't recognize, I might want to address it. If there's something here I see that's not normal. But as I scroll through them, if they're all normal, then I just want to leave this indication blank in preparation for the flow pattern. Okay, then I'll check my primary ICAS. Again, I could come up here and put this in engine because I want to check my ICAS indications, N1, EGT. I can check my duct pressure indications, my cabin altitude, landing altitude, the rate 0. The gross weight is here, what we put in. The total fuel, 149,500, because we're burning from the EPU. And N2, fuel flow, oil pressure, oil temperature, oil quantity, and vibration. I'm checking that they're all there. I don't want to see anything missing here, because if I do, it might be an EIU problem. So if it's in auto, it automatically selects the left EIU for these two displays. But if for some reason it was missing some information and it's maybe still in left EIU, but it hasn't switched to the center CIU because it's not a total failure, I might look at these and say, why is my EGT missing here? Why is this N2 missing here? You know, then I could try to come up here and go to the center EIU and see if that restores it. Because I might have a partial problem with the EIU. If I had a total failure, it would automatically switch to the center EIU. If these went blank totally, then it would indicate that the EIU is in auto and it didn't switch. And then I could take it out of auto and put it to center and see if these come back. So the normal sequence of switching is for this is left, center, and right. In auto, it'll select the left EIU. That's what's providing the indications here. This stands for EFIS ICAS interface unit. And if that wasn't, if that's not the problem, then it'll switch from left to center to right automatically. You don't have to do anything. So the only thing you would get if it changed from left to center is you might see a momentary blinking of the screens, and then they'd come right back. But you'd have a status message saying something like left EIU. It would be telling you that there's a problem with the left EIU. So I want to check the ICAS just to make sure everything's here, nothing's missing, and everything's good. And then from, let's see, anything else on there? I don't think so. And then from there, we want to go down to our, again, we've already done the CDU pre-flight, so that's kind of standing by on this page. And then we could come down to the aisle stand. And we're going to check everything here as the FO, except for the captain's audio panel. That's his job, to check that. And even though we kind of checked the rudder trim and the aileron trim, this is kind of captain's domain too. But we do check it just to make sure it's 0-0 at this point. So we'll just make sure the radios are on. You have an active and a standby frequency in there. In a lot of airplanes, this is an off light that would illuminate if the radios are off. In this configuration I'm in now, it looks like it's actually a switch. It's not a light. So if it's a switch, if you push it off and hold it, the radio would go, you'd turn it off, and the frequencies would go away. If you take it and you push it on, the frequencies would come on. I've never actually been in an airplane that has the switch like this. I've always seen it with the off light, and that off light should be extinguished. So if you have the, where you're in an airplane that has the off light, then it should be extinguished and you should be seeing frequencies. And you should be seeing VHF left for the captain's radio tuning panel, and VHF right for the first officer's radio tuning panel, and VHF center for the center radio tuning panel. And those light bars should be illuminated. And that's all we need to know for that for now. So we just want to make sure that the radio's on and the off light's extinguished, or in this case, we know it's on because we see the frequency. But that is a push button. That's not a light indication. We're going to skip this because that's the captain's. We'll make sure this is in data. So that's for the ACARS data automatically tuned. And observer's audio panel be as desired. If you have an observer, they'd probably want to change this to how they want it, but for us, we don't need to do anything as the FO unless we're helping the observer. Seatbelt signs, we'd normally turn them on now if they're off. And then our radar, we'd want to make sure that we're in weather plus turbulence mode. We probably want to make sure this is in left or right. We normally select in left. I don't know if you can see the little indication, but it indicates that it's a little alternate action switch, and so when you push it in, you'd be on the right radar receiver, and if you push it out, you'd be on the left radar receiver. So we normally keep it on left. We'll normally be in the auto mode, and again, the FO would want to make sure he's in weather turbulence. Again, we're putting them all in. Again, I'm checking this whole thing for the captain too. Make sure we're in weather turbulence, auto position, and we're in left is fine. Menu, we're not going to worry about here for ACARS. This is where we'd find our ACARS, where we'd set it, but we said we're not going to set it unless, again, it's in some AQP programs, they set it. I can't, hey Marco, if you hear this, I can't remember UPS. Do you guys in AQP, do you put information in here for ACARS, or did you just ignore it on lessons? Answer that if you could, if you're still here. I can't remember what we did with UPS. I think we maybe used it because there were little cards that showed what the ACARS information was. But for our training purposes, we're not going to use it. So I'll go back to menu here. And again, usually you'd see, ACARS, and you might see central maintenance computer, and you might see SATCOM, and you'd see some other things besides just ACARS. I'll check rudder trim 0, aileron trim 0. That's on the control column. You're checking that the control column says 0 as well. I'll check to make sure the rudder trim center is just out. It's a momentary action switch. Should be out. Again, no system status light. See that? Yeah, we won't worry about the call buttons. The right radio tuning panel. Again, we should see frequencies, VHF right. The off light should be extinguished if you have that, or it shouldn't look like that. In which case we want to turn it on. And that's about it for now. Frequencies we'll worry about later. Well, we could set up a couple of them now. No, let's not set them up now. Okay. Audio panel for the FO. Normally this would be on flight and speaker if you're doing an oxygen test of the microphone. But when you're done with it, normally you're going to go to right and speaker, or you might be using your headset and you don't need speaker. You probably have it on speaker because you don't want to wear your headset yet. And that way you're kind of set up for the radios, which are normally going to be tuned to your ATC clearance will be on the right radio tuning panel. Your ATIS will be on the right radio tuning panel. If you need to communicate with the company, usually the right radio tuning panel. And then over here on the left would normally be ground and tower and departure and center and things like that. So for now, if we wanted to, we could set the frequencies. Let's see if we got some frequencies here. Boeing Field, I'll just set them up for today. Boeing Field is, let's see, what is it? Looks like 2775 for the ATIS. So we'll go 27, oh, there it is, 75. That'll be the ATIS. Oh, you notice if I push it there, it'll probably start squawking. I don't know if you can hear that. I got the speaker up as loud as it goes, but the ATIS is broadcasting right now. And the clearance is going to be 132.4. So we'll tune that. So we've got clearance here, the 8 is here, and then over here we'd have ground. And so we'll put in 121, I think it's 9 here. 129 at Boeing Field. And we'll put in the tower, which Boeing Field is 120.6. So we'll put that in here. Many times in training, we don't necessarily take the time to tune the radios. Because it would, it takes a lot of time to look up frequencies, and 120, what is it, 120.6, yeah. So this is ground and this is tower. So again, like I was saying, many times in training, we don't take the time to set the frequencies because it can be a time waster, and we use communications, and we use the proper communications, but we're not necessarily changing to, departure, and we may go through the motions of doing that and actually change the frequency, but it might not be the proper frequency. Now that changes kind of in AQP. When you're doing AQP, and not in the maneuvers portion of it, we probably don't change the frequencies, but in the line-oriented training and the line-oriented evaluation, then we're changing frequencies, and we got the headsets on, and we're doing the proper communications. Because again, that is more line-oriented. But in your typical training environment, where you're doing hardcore maneuvers or procedures, we generally don't waste the time with changing frequencies. But today we'll show you how to do this, change the frequencies. And we'll set them up for now. In this one, in the standby window down here for the center, we would normally put in the departure frequency when we get the clearance. So I'll just tell you right now it's going to be 19.2, and I'll just set it right now just to save the time of doing that. So that'll be departure. When you call clearance delivery and they say, fly runway heading, radar vectors for blah, blah, blah. And departure will be 19.2, squawk 4343. Then we can put the departure frequency here, because we can't really fit it in here anywhere. So we got it here just so we can reference it when we need to change the departure. Then where was I? I was here. Okay, so we'd be on right and speaker, and then for the transponder, we just make sure it's in standby. And we go, if you're a really nice guy, we probably want to go to 2000. And that's just a reminder we don't have a clearance yet for a VFR squawk. And once we get the clearance, we'll put in the squawk. When we get down to here, we set our, adjust our seat and adjust our rudder pedals, and then we're done, the FO. We're just waiting to do the pre-flight checklist then. The captain, he's got a lot less to do. He's going to come over, his switch, remember, it would have been off. He's going to start here at the EFIS control panel, and he's going to go again, baro. Don't probably want to be in radio. I'll be in inches because I'm in the States. Flight path vector if you want it, yeah. Meters, we aren't in China or Russia, so don't worry about that. Map, range, 20 miles, that's fine for now. We could do it to whatever we want. We'll go to VOR, and we'll go to ADF. Again, that's how we do it at Boeing, just to check this and this. And then we'll go back to VOR. And again, we want to be in expanded mode. And so we're not in 360. And I'll bring the airport on. And you'll notice here the train was left on, so we're going to turn that off. Because I don't want to be in terrain or weather at this point on the ground. So I turn that off. TCAS off should be displayed, and if the IRUs are aligned, you could look for that now. If they're not, you'd have to wait till we get to here. But in this case, again, remember, if it wasn't displayed and the IRUs are aligned, you could go ahead and push traffic, and then that would bring up TCAS off. So for the EFIS control panel, basically the same things as the FO. Altimeter, I could set that, again, if I know it, I could set that as well. So I know that it's the ATIS, at least. I know it's 2992. If it changes, we can always update it. And then I'm in VOR, airport selected, and that's about it. Mode control panel, flight director on. Auto throttle arm switch armed. Bank angle limit selector auto. And the disengage bar should be up and not pulled down like that. When it's pulled down like this, there's a little red stripe across here that it's meant to be a visual indication that the bar is pulled. Now, a better indication really is that it's not flush. If you run your hand across here, this will be completely flush. If this is pulled down and you run your hand around here, you'll bump into this. Sometimes this red stripe, it wears over time and it's not there anymore. So these airplanes are old, some of them. So you might not see it very well in the dark, or it might be worn out. So really a better indication is just to make sure that it's flush here. And that would mean just run your hand across here and make sure it's up. And that's it for the MCP for now. Now we go down to our oxygen. Yeah, we could check our lights on the way down here. Maybe we already did that. But we check our oxygen, do the oxygen test if we need, which we would need to. And again, we'd hold the reset test, emergency switch, check the status page, and check for 10 seconds that the PSI doesn't drop more than 100 PSI on the status page. And check our foot and shoulder heaters, and then come up this way. Again, the oxygen is down here, but I can't show it to you on the Aerolinks because it doesn't have it. Come up this way. These should all be 12 o'clock. Your instrument source select switches, auto. Usually this is auto. This doesn't have the auto switch, but usually it's auto, and FMC left and left flight director. But again, they should all be 12 o'clock even if you don't have auto positions on these switches. 12 o'clock is usually the normal position. Clock, again, the elapsed time is running, so we'll get rid of that. We'll check the GMT time is correct. We can check the chronograph if we wanted to make sure it works. One push starts it, one push stops it, one push resets it. GMT time's good, and the clock is in run. RMI, VOR, no flags. And then we could check the PFD again, same things, blank, toga, FD, 8 degrees, pitch up, wings level. 30 knots parked is what we should see, ground speed 0, no V speeds because we haven't done anything on the CDU. Initial power up, 210,000 north, that's fine on the MCP. No flag showing, 2992 is set, field elevation looks good. And -8 on the radar altimeter is normal. So that's all good. Normal here, ground speed 0, check no flags, we have an active flight plan, TCAS off is displayed, and again the main thing here is no flags. You see no flags on the ground speed 0, I mentioned that I think. Come down here, brake source selector, brake source lights illuminated, that's normal because we have no active brake source right now. We have no 4 hydraulics, 1 hydraulics, or 2 hydraulics. They're off, so as a result we'd have the brake source light illuminated. The accumulator pressure is showing what's available for the parking brake, and right now it's good at 2,000 psi. We would need to pump. We could pump it up if we wanted to, using the number 4 aux to pump it up, but we won't do that. It looks good for now for what we need. Auto brakes, we go to RTO. Now the auto brakes on this configuration are right here below the ND. There's 2 places it could be. It could be below the ND, or it could be back on the center pedestal, all the way on the right side, all the way after the center pedestal. So it could kind of be either there, it depends on the airplane, again, what your jet is configured, or it could be, down here. So sometimes the auto brake is the duty of the FO, because the FO will come down here after transponder, and then he'll set the auto brakes to RTO. But in this case, it's actually the captain's area of responsibility because, let me position this right, because it's right here. So this is the captain's job now to set this the auto brakes to RTO. And that'll remain his area of responsibility. So as part of the after landing procedure, he's going to have to turn this off as well. It'll be in the disarm position, he'll turn it off. But again, normally it's either the captain's duty or the FO's duty, depending on where it is. In this case, it's the captain's duty. In the case where it's on the aisle stand, it's the FO duty. We'll check our ISFD. And again, we'll just make sure it's 30 knots parked, 2992, showing field elevation. There's no approach mode shown here. You know, if I saw that, I might want to blank those out. Depends on the airline whether you want to keep those on or off. Normally we keep them off. And then no flags in that display. If you didn't have this, you'd have the round dials, and you'd just be checking that those are all normal indication on the round dials. Then I come down here to the CDU, and if I'm the captain and the FO did the CDU pre-flight, I got to check what he did. So I'm going to go to FMC. I'm going to check the ident page, model, engines, active nav database. I'll go to pause init next. I'll check that the last position is the GPS position, which it is. UTC time is good. That's good. I'll go to the route, and whether again, the route, we put it in manually, origin, KBFI, destination KBFI, we're Sonic 44. Here's where we could copy the route that we put in, which is here. We could copy that into route 2, and we usually do that. We usually copy that route into route 2. So if you push route copy, it'll say complete. And then if you go to route 2, that route that we put in will be in route 2. Route 2 is inactive right now. If you go back to route 1 is active. So we normally would put that in, copy it in, just in case they change our flight plan and we'd have the old route in there. So as a matter of course, we usually do a route copy. I think Alter, I think, was asking that. So we're going to check the route. So we go to our flight plan and we check Orton, direct Vamps, direct Pane, Victor 23 Seattle, looks good. Departure, we're using runway 14 right. He's got that in there. We could also see that on the route page here. And there's no connection between the runway and your first point. That's probably good. Again, just cleaner that way. And once we're done with that, we could, here's where we have to modify things a little bit. I checked the route. Notice the next step in the pre-flight sequence should be perf init, but it's not there. Takeoff's there. So we need to get to the performance initialization page because that should be the next page in the pre-flight sequence. So you kind of have to know that performance page follows the route page. So if we go init ref, that'll take us to the takeoff reference page. That's the page it thinks we want to look at, but that's not the page I want to look at. So if I go index, that'll take me to the init ref index, and then if I go performance, that'll take me to the performance initialization page. So I do have to kind of modify this if I want to go in sequence. So again, just to review that, if I was in route and I checked my route, I determine this is okay. Also, if I'm flying an RNAV departure, I could go to index, I could go to position, and I could go to next page, and I could check the RNP, that it's usually 1 mile is required for an RNAV type departure, and our actual ANP is 0.09, so we're well within that 1.00. So if you're not doing an RNAV procedure, you don't necessarily need to check that, but if we're going to do an RNAV type procedure, we need to come here to position page 2 to check that. But again, if I'm on that route page and I'm done, and I've done this, I've gone through my route, and then I say, oh, I want to get to perf init, but it's not there. Okay, so I go init ref. That takes me to this page because that's the page it thinks that I want to get to. But that's not the page I want to get to. I want to get to perf init, so I select index. And that'll give me the init ref index, and then I select performance. And now I can check this. 480,000 pounds. Again, this should say calculated, really, but the zero fuel weight is added to the fuel to give you gross weight. And normally it would say calculated. And then when you bring the fuel control switches to run, this would separate itself from totalizer fuel. And this is fuel used based on fuel flow. And then the totalizer fuel would be shown on the progress page. And we'll show you that later. But this should say calculated, not sensed. But I can't make it go back to calculated, unless somebody knows how to get it back to calculated. Reserve 20,000, we check that against the flight plan. Cost index 125, that's all on our flight plan, remember. Cruise altitude 9,000, and we put a step size of 2,000 in there. Or if you were using the NG FMC, it would say RVSM. Or we could change it to RVSM if it didn't. So that's good, we check that. We go to thrust limit, we're using full TO, full climb, that's good. Go to takeoff, next step. And that's all in here, so that's all good. And we don't have our final numbers yet, so these are small. We don't have our final CG, so those are small. So we'd leave it like that. I stay on the takeoff reference page. He's probably staying on the takeoff reference page. Just as a reminder, we don't have any speeds in here yet. We don't have our final numbers yet. So if I check that, let me reposition this. So if I'm done with that, then I'm going to go to the thrust quadrant. Over here. So now I'm going to check the thrust quadrant, and you know, I can check my trim indicator if I want, just to make sure it doesn't say an op. There's no flags in here. Speed brake lever should be down. Forward thrust lever should be idle. Reverse thrust lever should be down. Flap should be up. Parking brake should be set. Fuel control switches should be cut off. Stab trim switches should be guards closed, and that would be in the auto position. If I bring the guard open, you'll see it is in the auto position there. But guards closed will bring it to auto. And the alternate stab trim switches are spring loaded to the center position here. So nothing really we need to check there, just that they're in the center. Now again, notice how I went. I think I went as it's written, this way and then this way. Again, is it wrong if you go this way and then this way? No, I like it better this way. I like better to go check the trim, speed brake, reverse, forward thrust levers, flaps. You know, I'll kind of look at his trim indicator too if I can see it. Then I'll kind of come around here and check that's middle, this is guarded, cut off, parking brake. Again, it's more of an S, and then you can come down here. But the book is written like this, left to right, left to right. So again, but would I have a problem with the guy if he did this? No, because he's checking everything. But if he deviated a lot from it, then I'd have a problem from the what's written in the book. So once we're done with that, we would check our audio panel. And again, we're probably in flight and in speaker from the oxygen check if we did the oxygen mask microphone check. So we're probably going to go to the left. And again, speaker, if we want to leave it on there, that's fine. Or if we have our headset on, we don't necessarily have to have speaker on. But we'd be in left VHF now in preparation for, you know, talking to ground or tower. This guy's in right because he's going to be calling for the clearance, the FO. And then I'd adjust my seat and adjust my rudder pedals. And then we're ready for the pre-flight check. Now, doesn't that take a long time? So, talking through all of it takes a long time, and I'm amplifying on some things too. So, at this point, once you get to the captain's pre-flight and it's done, he'd adjust his seat, adjust the rudder pedals, and then he would call for the pre-flight checklist. So let me hang on a second. Let me get the QRH here. And let me go to the checklist. And let me bring up the checklist. Okay, so normally at this point the captain would call for the pre-flight check. As long as the captain's done with his scan flow, the first officer's done with his scan flow, let's do the pre-flight checklist. Now, the pre-flight checklist, remember we said that in reality, Boeing does it as a challenge and response, but with areas of responsibility. And I mentioned that that we're not going to be able to do that necessarily. But today I'm going to do that. I'm not going to use Sylvan, which is the guy, the first officer Sylvan for the Aerowinks. When you select the Boeing option for the callouts and for the checklist, he would be the guy that reads the checklist. And so today we're not going to use Sylvan. We're just going to use the way we would do it at Boeing. So this is normally by area responsibility. And so if I call for the pre-flight checklist as the Capitana, where's my pointer? There it is. So if I call for the pre-flight checklist, the first officer is going to say oxygen. And then I'm going to say, is captain tested 100%? And then he's going to say tested 100% because he tested his oxygen and made sure the little toggle switch is in 100% as well. And that's his area of responsibility as well as it is my area of responsibility on my side. When he says flight instruments, that's the challenge. I'm going to respond as the captain and say heading. Right now the heading and track are the same, so I'll say heading 332, altimeter 299 or 2 inches. And we're actually checking it in like 5 different spots. You know, we're checking it here, the mag compass, which you can't see, which is up here above the mode control panel, and the FO is checking his heading and his heading on the ND. So you're actually cross-checking each other too to make sure the headings are the same. So you're only saying heading 332, altimeter 299 2 inches, but you're actually checking 1, 2, 3, 4, 5 places. And then he's going to respond to that as well, the FO, because that's because he's got his flight instruments to check. So he's going to say heading 332, altimeter 299 or 2 inches. So that's a dual response. And then parking brake, the FO would say, and the captain will respond set, because that parking brake is his area of responsibility. The thrust quadrant is his. It's not the FO's. It's his for pre-flight duties like this. And then fuel control switches would be the challenge by the FO, and I'd say cutoff is the captain. And again, I'm going to check that my fuel control switches are in cutoff. Again, this whole area is the FO. I'm sorry, the captain. Captain's area of responsibility right here, so he's going to be the one to check all that. He's going to be the one to respond to that on the checklist. So that's how the checklist is run. And we did talk about that, I believe. Let me go back to, and what I was pointing out, you couldn't see it. What I was pointing out is you're checking this heading. But what I was pointing out is you're checking heading here, and you're checking heading on your mag compass, which is above your mode control panel, and you're checking heading here, and you're checking heading here. So it's kind of like 1, 2, 3, 4, 5 places you're actually checking your heading. And then the altimeter, you're checking on your PFD, but you're also cross-checking on his PFD. That is, 2992. But the response is only where you say heading 332, altimeter 299 or 2 inches. Yeah, I see the pointer now. Yeah, you can see it. Okay, good. Yeah, I thought so. I don't know why it wasn't showing up before. Some strange things going on. Or something I'm not understanding about why the pointer didn't display. Okay, so once you're done with the pre-flight checklist, now this is where there's kind of a sequence of events. And in training, you have to just kind of get used to what that sequence of events is, because it differs from when you're on the line. When you're on the line, there's a lot happening. People are coming in. Loadmasters are coming in. Flight attendants are coming in on a passenger airplane. Mechanics coming in with a logbook. Gate agents are coming in. You know, there's a lot of distractions. And so things are happening, and you're doing things in between all this stuff that's happening. But in training, none of that stuff's really happening. You know, you don't have a lot of those distractions that you have in the actual line. So when you're on the line, it actually differs a little bit than what we do in training. But in training, you got to kind of have a sequence. So the sequence now would be that since we're done with the pre-flight checklist, we can now get the ATIS. We'll get the weather. So we'll pick up the ATIS, and we said that the ATIS, let me bring up the flight plan. Oops, that's not it. That's not it, that's it. So we said the ATIS was, I won't bring it on the radio. We could tune it on the radio and we'd hear it, but maybe you can't hear it. So ATIS information alpha, winds are calm, 15 statute miles, sky clear, temperature 15, dew point 8, altimeter 2992, the ILS 14 right's in use, departing 14 right, advise initial contact via alpha. Okay, so now that we got the ATIS, we know what that is. We got alpha, we wrote it down, or we pulled it off the printer or whatever, however we get it. And then we'd call for clearance and switch back over. Okay, so here's the radio tuning panel on the aisle stand. And if you're in right VHF, which we should be, we've got the right radio tuning panel, the right audio control panel pressed to mic. And we've got the speaker on if we want that on. And if we want the ATIS information, we would just put the standby, which is 12775, into the active window, and then we'd get the ATIS. And I don't know if you can hear it or not, but we already read it, so I'm going to turn it off. And this would be the clearance delivery frequency 132.4. So normally the FO would be in right, he'd be on clearance delivery. And if we're going to call for a clearance, you know, unless we're getting data link or something, if we're going to call for a clearance, then we go to right VHF and we would call for a clearance at that point. Now we're going to say our clearance for today, we won't even worry about the Ken 8. We'll just say it's runway heading, radar vectors to Orton, flight plan route, local IFR, climb and maintain 6,000, expect 9,000, 5 minutes after departure. Departure will be 119.2 and squawk 4242. And then we would, we would respond with a transponder code 4242, Sonic 44 Heavy. And we would have called them Boeing Field Clearance Delivery, Sonic 44 Heavy, local IFR to Boeing Field. And then he would have given us the clearance. Now, once we get the clearance, we can set up, and this is Boeing procedure now, remember we're talking Boeing. We can set up our transponder code 4242. So we have that in there. And my departure is 19.2. Now, would I set anything on here? Most guys, and it's a hard habit to break when you're doing Boeing procedures, most guys would want to reach up here and start spinning things, to set the heading in and the altitude. Well, with Boeing, we wait till we have the final paperwork. So, yeah, Captain Marco, if you're still here, so long. He's going, where's he going? Are you going to Hong Kong? All right. Captain Marco is a 747-400 and -8 UPS captain. And like I said, check out his videos. They're very good. So, where was I? Lost my train of thought. So when we are, what was I talking? Oh, the clearance. Okay. Here's what we do at Boeing. We wait for the final numbers. We aren't going to set anything until we get the final numbers. And so we got the ATIS, we got the clearance. We haven't set up, we set up the clearance as much as we could, which is the transponder and the departure. And now we're kind of waiting for our final paperwork. So let's say our final paperwork comes through now. We get it, we see the final zero fuel weight is 480.0. Well, that's already in there, I know, but I'll go back to the performance page and just check that. 480.0. So I can see that that's in there. I know this is a little small, but I'll keep it on here for now. 480. And the CG, the final CG is 25%. So now I can put my CG in. This would probably be the FO doing it. So he'd put 25 in the CG line. And that's going to give me my trim. It'll come up with a trim. And if it's a little too little to see it, it says 5.0. And now I could also activate my V speeds now that I have my final numbers. So I'll activate V1, it goes big. I'll activate VR, it goes big. I'll activate V2, it goes big. Okay, so now my final numbers are in, and I can set the mode control panel now. So now I can come up and set my V2 speed, which is going to be 158. So I'll come up here and set that. 158. That is 8, right? Yeah, 8. And then the initial heading would be a runway heading. So the initial heading is going to be 135 would be runway heading off of 14 right. I get that from the airport diagram, looking at 14 right. Runway heading is 135. And the altitude is going to be, we said the clearance 6,000. With the final being 9,000. And then, am I going to use VNAV? Yes, I'm always going to use VNAV. Am I going to use LNAV today? No, because the clearance is runway heading, radar vectors for Orton, flight plan route for the local IFR. So I'm not going to use LNAV because I'm not flying a SID. I'm going to use heading selected 400 feet. So I'll just keep it on LNAV disarmed. So I've changed 1, 2, 3, 4. I've set my V2, I've armed VNAV, I've set my heading, and I set my altitude. If I had a SID, I would also arm LNAV, and then that'd be 5 things that I've set. So once I've done that, then if you think about it, I got the ATIS, I did my cockpit setup, I got the ATIS, I got the clearance, we got our final numbers, we set the MCP, now I can do a crew briefing. And I'm going to forego that crew briefing for today. We're just going to say standard procedures for today. We'll do a more proper crew briefing as we go. So we've done the crew briefing. Now at this point, I'm looking for things like, are the doors closed? Are we getting close to the time where we're going to go? Okay, so we go to the door synoptic, and sure enough, the doors are all closed. That's good. And you know, the gate agent or whoever would have come up and said, yeah, you got your final paperwork and whatever, and blah, blah, blah. You got that. We got the dispatch release. You signed it. See you later, so long. And he leaves. And then pretty soon the doors are closed. The next thing I'd probably want to check is the external power removed. So if I go, and I'm going to switch, hang on a second, I got to switch. Now I got to switch the layout. Okay, so if I go to the overhead panel, you can see external power is still available. So they still got it plugged in. Now, at some point, they would have called us and said, you know, ground and flight deck, we'd like to remove ground power at this time. And we would have said, we would have made sure we're on APU 1 and 2. We've got it on. And then we would have said, go ahead and remove ground power or external power. And then he would remove it. So I'll do that now. Now, if he didn't do that, we could always call him. We could get his attention, and then he gets on the radio, and then we'd say, you know, flight deck, go ahead and remove external power. Flight deck to ground, go ahead and remove external power. We're on APU power now. And then he'd go ahead and remove it. So usually he's going to call us, but in the event he didn't and we wanted it gone, we could always get his attention and call him and remove it. So now we're just on APU power, doors are closed, and now we're ready to either get a pushback clearance In this case, we're at Boeing ramp. We're a freighter, or not. We're not a freighter. We could be a test aircraft, but we're at a ramp position. We're not at a gate position. So in this case, we probably just want to get permission to start engines from Boeing ground, and we'd call Boeing ground. Sonic 44 Heavy. We're ready to start engines, and he'd say, "Go ahead, clear to start. Give me a call when you're ready to taxi." And we'd say, "Sonic 44 Heavy, Roger." And then the captain would then call the ramp personnel, and he said, "Flight deck to ground." He said, "Go ahead." And then we tell him we'd like to pressurize hydraulics at this time. Now, we don't have to verify the nose gear steering is locked out because we're not at a gate, and we're not getting pushed back by a tug. So we don't really need to verify the nose gear steering is locked out. We're going to know it's not locked out, actually, from where we are. We're in a freestanding position. So we would just get permission to pressurize hydraulics, and he'd say, "Yes, you're cleared to pressurize hydraulics." And I'd say, "Thank you, cleared to pressurize hydraulics." And then I'd say to the first officer, "Before start procedure." And then that would be the cue for the FO to start the before start procedure. And what that's going to be, you're all seeing this, right? Yeah. What that's going to be, and can you see my pointer? Yep. You're going to come up and check that APU generator 2 is selected on. Because if you forgot that, for some reason, if they finished loading and you never switched to APU generator 2 and they removed external power, but you just have APU generator 1 on, if you go ahead and put the fuel pumps on, things are going to start shedding. And that's usually a good cue that, something's not right if I see the load shedding starting to occur. So the problem could be that you don't have two generation sources. So we want to make sure, as part of the first step of the before start procedure, that we check that APU generator 2 is selected on, which it is. The next thing would be to bring number 4 demand pump to aux, and number 1 demand pump, if you have it, to aux. If you don't have it, then this number 1 would go to auto. And then we're going to bring number 2 to auto and number 3 to auto. So it's aux, auto, auto. Number 4 we do first because that pressurizes the normal brake system first. We don't want to do number 1 first because that could move a shuttle valve, and you could get a slight transfer of hydraulic fluid if you're pressurizing the alternate brakes and the normal brakes aren't pressurized yet. So we always start with number 4. Number 4 to aux, number 1 to aux, number 2 to auto, number 3 to auto. Or it's going to be number 4 to aux, number 1, 2, and 3 to auto if you don't have an aux position for number 1, which some airplanes don't. Mainly on the freighters, they'll have an aux position for system 1. Then we're going to go ahead and turn the fuel pumps on. That'd be the next thing. And we're going to turn on all the pumps containing usable fuel. So we'll turn on these, we'll turn on these, and we'll turn on these. Now I know, because I checked the fuel load before, that 2 and 3 are greater quantities than 1 and 4. So I know that I'm going to turn on the override pumps as well as the main tank pumps. And I know there's nothing in the center tank pump. Now, if I didn't know that or I didn't remember, I could go down to the fuel synoptic and look at it. But in this case, I know that 2 and 3 are greater than 1 and 4 for the quantity of fuel. Nothing's in the center tank. So I'm going to turn on main tanks 1, 2, 3, and 4, and also the overrides 2 and 3. And all the crossfeeds are open. And even if it's tank to engine, I'm still going to do this. And then I'm going to get an ICAS message that says tank to engine, and then I'll configure to tank to engine. But for right now, I'm turning all the pumps on that contain usable fuel. And again, I make sure all the crossfeed valves are open. Center tank, there's nothing in there, so those pumps are left off. Then I'm going to bring the beacon to both. Okay, that's about all I do up here. So what did I do so far? APU 2 is on, number 4 to aux, and number 1 to aux, number 2 and 3 to auto. And I brought on all the fuel pumps containing usable fuel, made sure the crossfeeds are open. Nothing's in the center, so those are left off. And then I'm bringing the beacon to both. Now I got to go downstairs. So downstairs, I'm going to now select on the ICAS control panel, I'm going to select recall. And this is kind of a joint responsibility that when I push this, I want the captain to check it as well. So I'll push recall as the FO and I'll say engine 1, 2, 3, 4 shut down. And he'll say check. He's got to look at it and verify it, that those are the only ICAS messages that we have. We shouldn't have any other ICAS messages but that. That's it, just these 4. And then I can push cancel again. So I push this, recall, engine 1, 2, 3, 4 shut down. Captain says check. I cancel them. And then the captain, he doesn't do much. Again, he's going to check the mode control panel just to make sure it's set up again properly, but there's nothing he should have to set. And he's going to set the trim. So, oh man, my control column's way down here. So, hang on, if I can find my control column, I got to set the trim. So we said the trim was 5 units. I'm not really set up for a flight, so I got to reach down here. So you can see I'm setting the trim to 5 units right here. And you notice that is in the green band. That's what we want. And then I would call for the before start checklist. Make sure we did everything here. Let's see. I'm also going to check that the rudder trim is 0 and the aileron trim is 0. Now in the aero winks, we don't have a control column that we can look at to see that the aileron trim is 0. But on top of the control column, there'd be a scale, and it would show 0 and then units to the right and units to the left. And we want to make sure that says 0, just like this rudder trim says 0. So I'd be checking 5 units that I've set, and 0 for the aileron, but I can't check that in aero winks. Although it says 0, you can see here it says 0. That it's set 0. That's probably why they have that blue indication there, because you can't really check the control column. And then I'll call for the before start checklist. So let me pull that up. And here's the before start checklist. Okay, so again, I would call before start checklist. And the first officer would get out the QRH, open it up to the checklist, and he'd say before start checklist. Now he's going to skip 109 because we're a freighter. He's going to know we're in a freighter and that we're not 109, which is a passenger airplane. So he's just going to start with passenger signs. And he's going to say passenger signs are on, and he responds to that because that's his area of responsibility. I don't have to say anything as the captain. So he'll say passenger signs on, MCP. And now that's the challenge, and he's waiting for a response. So I, as the captain, will say V2 158, heading 135, altitude 6,000. And he doesn't have to repeat that because this is my area of responsibility. It's not his. So I respond to it, he doesn't. Then the first officer will say takeoff speeds. And I will say, as the captain, V1 127, VR 139, V2 158. And then the first officer is going to repeat that, but he's looking at his CDU because we want to make sure these agree, because this is calculated by the left FMC, this is calculated by the right FMC. So we want to make sure they agree. So he would say V1 127, VR 139, V2 158. So that's a dual response. Yeah, and I'll show you this on the screen here in a second, on the panel here, because you can't see that. You're just looking at the checklist. In fact, let me go back to the checklist. Sorry about that. I thought you were looking at the checklist. Okay, you Patreon guys have the checklist anyway, so let me start this all over again. So on the before start, the FO is going to say passenger signs on, because that's his area of responsibility. He'll say MCP, and then I'm going to respond as the captain, and now you can see this. V2 158, heading 135, altitude 6,000. And that's all captain says. FO doesn't reply to that because that's his area of responsibility. Oops. And then the first officer would say takeoff speeds. And I would look at my CDU and say V1 127, VR 139, V2 158. And then the FO is going to look at his side and say V1 127, VR 139, V2 158. Because that's both our area of responsibilities is to check the V speeds in the CDU. Then he's going to say, the first officer is going to say CDU completed, CDU pre-flight. And the captain is going to say completed, and the first officer is going to say completed. It's a dual response because you completed yours and he completed his. So it's a dual response. So CDU pre-flight, completed, completed. Trim, that's just the captain response now. So he's going to say 5.0 units, 0 and 0. And he'll look at the control column, not here. But he'll look at the control column and see that it's 0. Taxi and takeoff briefing, completed. Whoever did it would say completed. Beacon, both. That would be the FO saying the challenge and the response because that's his area of responsibility. And then he would say before start checklist complete. That's the way it would be done by Boeing, but when we do it from here on out, it'll be the way that it'll be just be challenge and response because we'll be using Mr. Sylvan on the next period. First Officer Sylvan. Okay, and then we're ready, basically ready for engine start. So we'd call the ground personnel or the ramp personnel that are in the nose and say we're ready to start sequence 4321, and he'd say you're clear to start all engines. We've already got permission from ground that we're going to start engines. He said give us a call when you're ready to taxi, so we can go ahead and start the engines now. So when we start the engines, just prior to start, especially in a passenger airplane, we'll turn off the 2 packs. You could have turned these off a lot sooner, but for passengers, it's we want the cooling or heating as long as possible. And then just prior to start, the FO would turn these off, 2 packs or 3 packs. It depends, but normally it's 2 packs off, and that's adequate, leaving 1 pack on. And then we're going to use auto start, so the captain would say start 4 and 3, and the FO would reach up, and he would pull the start switch for 4, pull the start switch for 3, and then the captain would come down and bring the fuel control switch to run for number 4 and to run for number 3. And then we're going to come over to our ICAS display and we're going to check that we have rotation. We have oil pressure. And we have N1 rotating. And then we're going to have fuel flow and we're going to have light off. Now again, the only thing we really need to check for is oil pressure and N1 with the auto start on the 400. The auto start system does not monitor N1 and it does not monitor oil pressure. So we have to, if there's no oil pressure, we'd shut it down. If there's no N1, we'd shut it down. Otherwise, things like a hot start, hung start, no light off within 25 seconds for the GEs, that stuff would all be taken care of by the auto start system. So we'd have 3 and 4 are stable, and then we'd probably call the ramp guy saying, okay, we're starting 2 and 1. He'd say you're clear on 2 and 1, and then I'd say start 2 and 1 to the FO. I'd also probably tell him go ahead and cancel that message. We know what that is. Hydraulic pressure demand 4 is there because that's normal, that the number 4 demand pump is in aux and it's inhibited when you're in aux. So you will get that when you start, you'll get that message. So we would just go ahead and cancel that. And then I'd say start 2 and 1. FO would pull 2, pull 1. And then I would go ahead and bring the start, the fuel control switch to run on number 2 and to run on number 1. And then I would take my hand off the fuel control switch and rest it on my knee. I don't want my hands on there because auto start is automatically going to terminate the start if there's a problem. And I don't want to be spring loaded with my hand on here. So again, basic thing I'm looking for is oil pressure and N1. And I can still monitor like I'm doing a manual start. I'd still see that I got rotation, I got oil pressure, I have N1, I have fuel flow, I have light off. And then you can see when it peaks and stabilizes, the red tick marks disappear from the EGT, and then the engine would roll back to being stable. You're going to see sometimes people use the 246 method here, where they look at we should be around 25% here, around 65% here. I'm sorry, I skipped this one. And about 400 here, 300 or 400 degrees centigrade here. So sometimes people use 246, but it works out to around 25%. About the high 3s, 400 degrees, and then here would be around 65%. That's normal. The main thing is that the tick mark went away on the EGT. The engine stabilized. At 50% N2, the start switch would go in. So that would have popped back at 50%. And then I'd see this hydraulic pressure demand 1. I'd go ahead and cancel that. We know what that is. And then I would probably call the guy in the nose now and say, flight deck to ground, we got 4 good starts. You're cleared to disconnect. And show me the pin on the left side. And he'd say, okay, clear disconnect, and your nose gear steering is not locked out, and we'll show you the pin on the left side. Have a good flight, so long. And so they'd disconnect from the interphone. He'd walk off to the left side of the airplane. He'd wave the pin. He'd show me the pin and give me a wave off. Meanwhile, I'm telling the FO now, before taxi procedure. And then we do the before taxi procedure. Now, Boeing calls it before taxi, but some airlines could call it, you think the term would be after start procedure and checklist. But Boeing calls it before taxi for whatever reason. But some airlines will call this, when they modify it, they'll call it after start. But for Boeing, we would say before taxi procedure. And then I would run into the before taxi procedure as the FO. And where I start, I'm going to start with the APU. So I'll start here and I'll bring the APU off. I don't need it anymore, the engines are running. I'll bring number 1 to auto. I'll bring number 4 to auto, so they're all in auto. I'll come over here to nacelle anti-ice and pause for just a second because that's the flow. And do I need it on or do I not need it on? On the ground, auto doesn't work. So if we had a temperature that was, if we had visible moisture and the temperature is below 10 centigrade, I'd want to bring these on. But in this case, I'll just pause there for a second. I know I'm 15 Celsius and there's no visible moisture, so certainly I don't need it. So I just pause here and say, it's in auto. I don't have to say anything. I just kind of check it. And then I'll come over here and bring the aft cargo heat on, bring the packs on. And then I'm going to come down and bring the flaps to 10. Oh, I got to get my control column again. Shoot, I forgot about this. Hang on. I don't have my control column really set up for this, so I got to reach to get it. I think that's the flaps. Yeah. So again, just repeating for right now, the APU is off. Demand pump 1 to auto, demand pump 4 to auto. Nacelle anti-ice, do I need it? No, I don't need it today, so just leave it in auto. Aft cargo heat on, packs on. And then I've come down and I've selected flaps 10, and the flaps are moving to 10. I'll also now come down here and select status. Actually, I probably would have done status before I did the flaps. So I'll select status, and then I'll go come down and go flaps 10. And then I can come down to my transponder and select transponder, because I want that for ground tracking. We have to be in transponder on taxi out. And then the captain, again, remember the captain doesn't have that much to do. The captain is going to say flight control check. And then that'll alert the FO that I should be looking along with him at the flight control check. And he would check that hang on, my column's not set up, so I got to reach way under my desk to get it. So I'm going to go right aileron first, and I'll bring the right full displacement, and I'm going to see, can you guys see this? Yeah, I'm going to see 3 up and 2 down. 3 up, the 2 ailerons are up, and the spoiler is up. And the 2 ailerons are down on the left side. So I'll go, some people say this, I like to say it myself. 3 up, 2 down, neutral. And then I should see neutral indications. And then I'll go to the left, 3 up, 2 down. Oops, 3 up, 2 down. 3 up, 2 down, neutral. And then I'll push the elevator forward as the captain's doing all this. And I'll say 2 down, neutral, 2 up, neutral, and then I'll hold the tiller, and then I'll go 2 right, neutral, and 2 left, neutral. And when I'm doing this in the airplane, you don't want to slam the control column. You don't want to go whack, 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 whack. You know, it's a smooth turning of the control wheel to full displacement. Because that's, it's 3,000 psi of hydraulics going out there, and you don't want to slam it to the stop. So it's a slow control column movement, right and then left and then down and then up, and then we hold the tiller so the nose wheel doesn't move, and then we go 2 right and 2 left while we're holding the tiller. And once that's done, we're checking for free and correct movement. They're moving in the proper direction. They're also the proper displacement, which is full. And then we'll go ahead and once that flight control check is done, the FO will reach up here and go take off the status display and blank it for takeoff. And then he'll push recall. And he'll check that we'll both check that there's no messages for recall. And you can see when I push recall, I get this little recall right here for 1 second. And that tells me that I pushed recall, but it's blank right here. And then I would call for the before taxi checklist. Okay, again, we'll do this 1 time. And that's how we're going to do it the Boeing way. So here's the before taxi checklist. And again, I'm going to go back in case I want to... no, I can stay here, I guess. Now let me go back, because you guys have the checklist. So I'll say is captain before taxi checklist, and then FO will say before taxi checklist, and he'll say anti-ice is auto, recall is checked, auto brake is RTO. That's all him saying that. No, I'm sorry, hang on. Not when the auto brakes are here. If the auto brakes were back behind, he would say that. But this is the captain's responsibility, right? Because it's right here. So he would say, the FO would say, anti-ice is auto, recall is checked, auto brake. And the captain's going to say RTO because he put it in RTO. That's his area of responsibility. Flight controls. Again, we both checked them. So he's going to say checked, and I'm going to say checked because we both verified that they're checked. And then ground equipment, clear left, clear right. You would normally say, captain would say clear left, first officer say clear right. And then before taxi checklist complete. And then I'd say, okay, let's get taxi clearance. And so now we'd tune up ground control. You know, the FO would probably go here to left VHF. And remember, the left VHF was tuned to ground. So we would call ground control at this point and say, you know, the Boeing field ground, Sonic 44 heavy taxi. And then the ground would say Sonic 44 heavy, roger, out of the Boeing ramp, runway 14 right, holding point Bravo 4, or Bravo 1, I guess it is here. And then we'd say, okay, taxi 14 right via holding point Bravo 1 for 14 right, Sonic 44 heavy. And then we're ready to taxi, so I'd probably tell the FO, taxi light on. FO would come up here, turn the taxi light on. And now we can start our taxi. So, oh boy. Hang on one second. So I'm going to release the parking brake, if I can get it. Okay, parking brake's released. And how did I see that? Right here. Memo message. I release the parking brake, and I look here to make sure the parking brake is released. And then I would go ahead and start the taxi. I could bring my range down, since I don't have a visual. Here, I could bring my range down to the lowest range. And then I would just add a little bit of power. Now, how much power do you add here? Well, it depends on how heavy you are. We don't want to exceed about 40 to 45% N1, because these are big turbofan engines. There's a lot of mass flow through the engine. You don't know what you're going to blow away if you add a lot of power. So the heavier you are, the longer it's going to take to move. So generally, when you add power, you got to give it time to start moving. So I don't want it, if it doesn't move when I give it, 40% N1, I don't want to then slam it to 50, 60% N1. I just got to wait till it starts to move. Now, I'm light today, so it's not going to take much to get the jet to start moving. So I'll add a little bit of power here. You can see we're moving already, ground speed 1. And then I'll use my tiller, which I have on my thrust lever, which is kind of sensitive. I'll use my tiller to come out of the Boeing ramp. So I'm coming out of the Boeing ramp. You can see we're ground speed 6. Now, as we taxi, I would probably tell the FO, let me get this tiller. It's very, very sensitive, this thing, for me to taxi. So as we taxi out, the captain would say, okay, I'll be in weather, you be in terrain. He'll specify who's in what. And let's say I'm the pilot flying as the captain, so I'd normally be in weather. I could take terrain too. In fact, I'm going to take terrain when we do the lessons, because I don't care about the weather, but I do care about terrain. So I'll probably put on terrain as the captain. But normally it's weather for the pilot flying and terrain for the pilot not flying. Let me slow my speed down a little bit here. Get that down just a little. And then, I would normally mention something about the briefing. So I might say something like, okay, the briefing's the same, runway heading, radar vectors for Orton, 6,000, expecting 9,000, squawks in the box, 19.2's departure, or I just say standard, no changes. Stop the airplane right here, if I can get my brakes. Brakes. And then I would say before takeoff checklist. So taxiing out, there's not a lot to do. I mean, it's basically you start the taxi. The taxi light comes on. And as you're taxiing out, you would probably say no changes to the briefing, or if there are changes, you'd say what they are. And then you'd say, I'll be in weather, you be in terrain. And then I'd say before takeoff checklist. And then the FO would say, before takeoff checklist, flaps. And then I would say 10. And he would say, before takeoff checklist complete. Now he's verifying that there's 10, but he doesn't have to say it. It's not a dual response, even though I think it should be. It's not. But we are checking that it's 10, it's green, it's 10, 10, green. You know, if the handle's in 10, it's a green indication. It says 10. So some people refer to that as 10, 10, green. So if the handle is at 10, the flaps are at 10, and it's showing a green indication. And then that would be it. We'd continue taxiing. We'd get close to the end. As we get close to the end, the ground's probably going to say Sonic 44 Heavy. You can switch to the tower. Go ahead and switch to the tower. Sonic 44 Heavy, thank you. And then we'd switch to the tower and we'd tell them we're ready for departure. So as we say, let me go to this screen now. As we call the tower, we would then say Boeing Field Tower, Sonic 44 Heavy, ready for departure, runway 14 right. And then the tower would say Sonic 44 Heavy, line up and wait, runway 14 right. And line up and wait, runway 14 right, Sonic 44 Heavy. Now that would kind of cue the FO in that he can do his flow. And he's got a flow, but there's no checklist to it. He's just got a flow. So he's going to turn on all the lights that he wants to, or that the captain specifies. And so we'll turn on the outboards, but the inboards will not come on until we're clear for takeoff. Turn-offs can come on, or they could have been on during taxi too, if it's night. We'll bring on the strobe light, and we can even bring on the wing illumination light if we want maximum visibility. And then I'll bring the transponder to RATA. Oops, there it goes. RATA. And then we're both going to verify that the airplane's turning. Hang on. I got to get to my control column. The airplane's running away. I don't have the parking brake set because that's on the control column. I can't get to it right now. Let me add some power and turn this around here. I am not set up for flying, am I? I was thinking, well, there's no flight today, so I have to set up the control column. Well, yeah, you kind of do. Brakes a little bit again. Okay, so we'll line up and wait, runway 14 right. Got a very sensitive tiller here. Yeah, as soon as I get it in position, I'll say that's good enough. We can start turning back. A lot of times in the FTD, you actually do not taxi because there's no visual and there's no point in taxiing. You might not even have a rudder pedals or a control column usually in the FTD. So usually we don't taxi, but we're kind of doing a full deal here. Brake a little. And we'll get back to the runway here, more or less. Oh, this tiller. Hang on a second. The tiller does not want to cooperate. It's a very sensitive tiller. I got it on a little rocker switch, and it really doesn't work that well. But that's the only switch I can put it on. Okay, good enough. I'll stop the airplane here. This time I'll make sure it's stopped. Okay, so we're line up and wait. We would have also, very important, we would have checked the signage that were in the approach end of runway 14 right. We would have checked all the markings that were on 14 right. When we take the runway, we'd make sure the runway numbers say 14 right. And we verify on the ND that we have runway 14 right selected. So we're making sure we're kind of paranoid about being on the right runway because of the incursions. So we want to make sure that the signage says we're on 14 right. It's okay to take the runway. Once he clears us for takeoff, then we're going to go ahead and the FO would turn the inboard landing lights on. And then we'd be taking off. Now what we're going to do today is we're going to bring the auto brakes off. Oops, disarm. I'm going to extend the speed brake. Okay, and we're going to say that we just landed. So we're going to say we're just clearing the runway like you see we're doing here to a taxiway. And as I clear the runway, get that speed brake back out. When we clear the runway, I would say to the FO, number one, we'd clear the runway, we'd call ground, we'd get our taxi instructions, and we would start to taxi and make sure we know where we're going. So we're not doing anything until we until we call ground. And then once we get our taxi instructions and the captain knows where he's going and everything, then the captain will say after landing procedure. And the after landing procedure, the captain would get the speed brake down. I'll come down here and do it. See, because the speed brake would be out. So we'd take the speed brake, he'd move it down. That's part of his flow. He would turn the weather radar off on his side, and because he controls the auto brakes, he would turn the auto brakes off. So he does those three things: speed brake, weather radar, auto brake. That's his job. Everything else is the FO. So the FO is going to go to the overhead panel. And he's going to start the APU. We could wait, but I mean, in most cases, it's not that long a taxi. And we're going to want the APU running for shutdown. So he'll start the APU. Then he'll come down to his lights and turn all his lights off. So all your lights off. Outboard, inboard, turn off, taxi. Strobe lights off. And then he's going to come down and bring the flaps up. Oh, I got to do that on here again. So the FO is going to bring the flaps up. I'll stand by while I do it. Let's just make sure they're coming up here. So the flaps are coming up. And he's going to bring the transponder to transponder. So this is all part of the after landing procedure. So what did he do? Again, on the overhead panel, he started the APU. He brought all the lights off. And then he came down and he will, well, I forgot one thing. He will turn his terrain off. Then I'll bring the flaps up, and I'll bring the transponder to transponder for the taxiing. And then there's no after landing procedure for that, and that's all he does. And the captain, he did those three things: speed brake, weather radar, auto brake. First officer, start the APU, turn the lights off, come down and turn your, in this case, terrain, because you had terrain on. Turn the terrain off, bring the flaps up, make sure the captain put the speed brake down. We look over there just to make sure, in case he's busy doing something, he didn't get it. And then do the transponder to transponder. And then we're taxiing in. There is no after landing checklist, so that's it. We're paying attention to where we're taxiing. We pull up to the gate or the ramp or whatever. stop the airplane. We'd set the parking brake. Let's see if I can do that. If I can, oops, where is it? Where'd the parking brake go? Here it is. Okay, let me try to set the parking brake here if I can do it with the, oops, the mouse isn't there. Hang on, I'll set the parking brake. Okay, so it's set the parking brake. And then the FO is going to be the one to kind of start things here. Let me go to the overhead panel. So the FO would come up to the APU and select APU 1. Notice we have to select it, otherwise we don't want to shut down the engines with no power. And there's no power when it just says available. When it just says available, we have to select something on. So we select APU generator 1 on. We'll leave APU 2 available for the main deck cargo handling bus if we're a freighter. If we're not, we could push that on as well. Let's pretend we're a passenger airplane. We'll turn that on now. And then I would come down and I would bring the number 4 to aux and number 1, 2, and 3 off. And now that's the cue right here that the captain can shut them down. So I bring APU 1 on, leave APU 2 available if it's a freighter. If it's not a freighter, APU 1 on, APU 2 on. Number 4 to aux, and I want to do it in this order. Number 4 to aux, number 1, 2, and 3 off. That's the cue that the captain can now shut them down. So the captain would come down and bring the fuel control switches to cutoff. And usually it's 1, 2, 3, 4. You could go 4, 3, 2, 1. Nothing wrong with that, but usually it will start left to right. So 1, 2, 3, 4 off. And then the rest of this is mainly the FO. Oh, I know why this is confusing, because I'm still on the engine start. Hang on one second. Let me change the layout here. Yeah, okay, that's why. I've got a layout for flight, and this is kind of a layout for the cockpit setup, just so we wouldn't have to fumble around all over the place, and I'm still fumbling. So at this point, when the engines are shut down, the FO will come down and turn the seatbelt sign off. And then he's going to come back up to the overhead. And he will then go ahead and start with the fuel pumps and turn them off. Now, here's the sequence. Sometimes what happens is they will chalk the airplane. And when the airplanes are chalked, they'll give a signal that the airplanes are chalked, or they could get on the airphone and say, chalks are in. And when the chalks are in, the FO's job is to come over here to the number 4 demand pump and take it from aux to off. Not that way, that way. So he's going to come down like this. He's going to go from aux to off. And then the captain will then release the parking brake. Or he could keep it on. It's his choice. But, I mean, usually you can release the parking brake when the chalks are in. And some guys may prefer to leave it on. Then the first officer is going to complete his flow. So he's going to take the fuel pumps and turn them all off. He's going to take the beacon and turn it off. Then he's going to, let's see, anything else up there? No. Then he's going to come downstairs here and turn his flight director off. Then he's going to select the status page and make sure there's no status messages, because if there are, they could affect dispatch on the next segment. So we're checking to make sure there's no status messages. Some airlines will go here to index and maintenance and IRS monitor and check the error of the IRUs and write them in the logbook. But we're not doing that, but some may do that. And after he selects the status page and checks if there's no status messages, he'll come down to the transponder then and go to standby. And if he's a really nice guy, he'll put it at 2000 for the next crew, that it's a VFR code. And then the captain will call for the shutdown checklist. Back up here. And the shutdown checklist would be, the first officer would say, shutdown checklist. Hydraulic panel set, fuel pumps off, and let's go just so you can check that. Let's go back up here. Hydraulic panel set, fuel pumps off, flaps up, and they are here. And that's all him saying that, because that's all his area of responsibility. And then he'll say parking brake. Well, that's the captain's area of responsibility. So the captain will say released in this case, or set if he leaves it set. But the chocks are in, so he would say, released. FO will say fuel control switches. Captain will say cut off. That's his response because that's his area of responsibility. And weather radar off. I'd say it as the captain because I had the weather radar on. And now I have it off. I turned it off. It's part of my flow. And then he'll say shutdown checklist complete. So that's the shutdown checklist. So again, just to review, what do we do? Shutdown checklist. We're going to make sure we have APU1 selected, or APU2, or both. And then number 4 to aux. Number 2, 3, 4 to auto. Or sorry, number 4 to aux. Number 1, 2, 3 off. That's the cue the captain can shut him down. He shuts him down. FO turns the seatbelt sign off, comes up, turns the fuel pumps off, turns the beacon to both, comes down here and selects the status page, turns his flight director off, checks for any status messages, and then we'll come down and bring the transponder to transponder, and then shutdown checklist. And again, responses, 3 of them are from the FO because that's his area of responsibility, and then the other 3 were the captain because those are his area of responsibility. And then if we're going to leave the airplane, we can now leave the airplane, do whatever we have to do to situate the logbook or whatever, and we're out of there. Or we could do the securing procedure and securing checklist if we're going to secure it. So if we're going to do a securing procedure, we'd say secure procedure. And then the FO would launch into it. He's going to turn the IRUs off. And again, you could check the IRUs errors before you do that. He's going to turn the aft cargo heat off. He's going to bring the packs to off. We're missing something. What is it? Oh, he's going to bring the IRUs off. It's because it's not showing here. I have to come down here. He's going to bring the IRUs off. He's going to bring the emergency lights off. So we'll lift the guard, go to off, lift the guard, go to off. And then he's going to turn the aft cargo heat off and then turn the 3 packs off. And then the captain would say securing checklist. And this is all FO. The FO, because it's his area of responsibility, the FO would say IRSs are off, emergency exit lights are off, packs are off, secure checklist complete. Okay, let's do the electrical power down procedure. And again, if we're going to shut down the airplane completely, including powering it down, then we would do the electrical power off procedure. And that's going to be in the in the QRH. And that'll be under electrical power down. You know, so here it is on the procedure. So electrical power down says this procedure assumes the secure procedure is complete, which we just completed. APU switch and or external power switch off. Standby power selector off. And then when the APU has completed the shutdown cycle, which we time for 2 minutes, then battery switch off. You'd have to wait 2 minutes because you lose the APU fire detection if you turn the battery switch off too soon. The protection's on the hot battery bus, so you could fight a fire, but you wouldn't know you had one if you took the battery switch off. So generally, when we shut down the APU, and let's say that's the only source, we'd time for 2 minutes. And then after 2 minutes, we could turn the battery switch off. Before we do this, we'd normally turn down all the lighting. We're not going to do that today, but we normally turn down all our lighting, and then we would go ahead with the shutdown, the electrical power down procedure. So let's do that now. We'll turn the APU selector. Let's say we turned all our lighting down. APU selector off. Standby power selector off. And now we'd time for 2 minutes. And after 2 minutes, we turn the battery switch off. And then electrical power down checklist is complete. And then if we look, we're back to a dead airplane, completely dead airplane. Okay, so that's it for FTD1. Long, I know. But that's talking about everything. So does anybody have any questions, if anybody's still here? Maybe you might all be saying, I'm going to just watch the recording in pieces instead of staying here. So if nobody, everybody may be gone for all I know. Any questions before we wrap up and leave? Did I hit the record button, I hope? I hope I hit the record button. Yeah, I did. Good. Somebody's still here. Charles, you're still here. When does the captain turn off the FD? Did I miss that? Yeah, I probably missed that. That's actually the only thing he does. Let me think about it for a second here. That's part of the, not the securing, but that's part of the shutdown procedure, is he would turn his flight director off, and I think that's it. Oh, watch the replay. So yeah, the captain would turn off. I might have missed that. The captain would turn off the flight director as part of his shutdown procedure, and he would have shut that down. I might have missed that. It's actually pretty challenging to sit here and talk about this and do all the procedures and not miss something, since I'm not referring to anything. So I think, yeah, check it, Charles, but I think it's when it's part of the shutdown procedure. I believe that's the only thing he does, but I'm kind of brain fried right now. Any other questions? Ahmed, thank you. You're here. The devoted are still here, I guess. Some people probably said, oh, heck with this, is too long. I'm leaving and watching the replay. Any other questions? Okay, thanks for attending. Next Monday, will be FTD Briefing 2. And then when we do the FTD portion of the flight, then I'll have my control column set up. I had it kind of stowed away under the desk thinking I wouldn't need it, and I actually did need it today. Thank you for attending, and I'll stick around for a little bit, so if you have any questions, just go ahead and put them in the chat box. I'll have it open for about another half hour or so. And for the Patreon members, the recording, once I get it edited somewhat, just to make sure there's no wasted spots in there, then I'll put it in the live stream recorded section of Discord, so that if you did leave, or if you want to view it again, it'll be in there. Yes, thank you all for coming, and have a good evening or a good afternoon, and or a good morning, I guess, depending where you're coming from. And we'll see you next week. Captain Al, out.